Okay, so a little bit of the course introduction I've already done, as you can probably tell. I am going to use the slides obviously as a guideline, but I reserve the right to go off the rails if necessary to draw things and show things. I already talked about breaks and lunch, so if you're wondering, next break is going to be in about an hour and a half, so that would be 11 o'clock. We are going to stop at 12:30, so just a reminder. Let's see. You can figure out the virtual classroom, right? You've already learned chat. We're probably used to this stuff already. If there's any material, by the way, I probably will actually post it up in the material section. Do note that usually about 24 hours after we end the class, I'll send you an email with some of the reference links, especially for the well-architected labs and pieces like that, just to make sure that you have it. So if you miss it here in chat, for the most part, I'll send you an email that has a summary. Do note that I post new links and discover new things all the time. So if I post a link in chat, you probably want to grab it because I won't necessarily have it on my list because that list changes like every month. Okay. So you all have already all been remarkably participatory. So let's just keep doing that. And then we do have labs. The labs are recipe driven, but that's done on purpose so that you can kind of look, understand the context, and kind of learn how to do things. Because that's really all we do is we build these skills where we're able to do like things at a repeatable level. And then once we do that to a certain extent, then we can start to improvise. So think of it a little bit like learning jazz. You got to learn the rules of music before you can start to break them, right? So we're going to give you some rule sets as you increase your skill sets with AWS. Then you can start to improvise. We do recommend that you have, some equivalent knowledge, even if it's just you experimenting on your own with AWS. We will talk about things like CIDR ranges and networking. We will talk about things like hard drives. If you do not have like the fundamentals of computing, that's going to throw you off. But from what I've seen thus far, you might be a little rusty at certain areas like we all are, but you're going to be fine. So I'm not really seeing anything to be worried about. Please note that if I talk about something that sounds like I'm assuming that you know, and you're like, Michael, can you explain that a little bit better? I'd be glad to. Okay. So just make that a priority. Ask me. All right, here's the objective. The official objective is to understand best practices around resiliency, security, high availability, costing on, for IT solutions on AWS, to understand some of the common core services. This isn't a machine learning class. This isn't an IoT class. This isn't really like a coding class. Obviously, it's an architecture class. We're going to talk about some things relevant to just core like application hosting. So mainly virtual machines, mainly containers, mainly serverless. If you haven't heard those three terms, good. Maybe you've already picked something up. But virtual machines, containers, and serverless are the three ways in which we host applications now. And this has been true since 2014, 2015, probably pretty mainstream as of 2017, 2018, at least in the private sector. So if you're not familiar with containers and serverless, then you are in the right place because that is the way things are going to be deployed for the next 10 years. Hands down, no argument. This is where the entire industry is headed. And I got to tell you, I fought it for a long time. And it's just the way things are, right? I'm like, do we really need? Yes, we do, apparently. So that's what we're going to do. Talk about a bunch of services, get their features, understand the distinctions between them, and how do we apply these abilities, resiliency, security, high availability. How do we apply that to these services? Okay. We talked about this already, right? And I kind of set some expectations for the course, but just know that if you have something that you want to see, you can ask for it, but the course is kind of scoped towards a certain outcome. So just want to make sure that we're meeting that outcome. Okay. Do note that as part of Amazon's desire to maybe perhaps be a little bit more business oriented, there's kind of these business pieces that are thrown into these slides now. I have mixed feelings about it because I believe all IT people should be business oriented, but most people who come to the classes just want the technical information. They don't want business training. So just know that I might come at this a little lighthearted. If you want to go deeper on this, please let me know. I mainly work as a digital transformation specialist with large companies. So I can talk about this all day long, but I also like to talk about the engineering side of things, which is where stuff happens. So, you know, they're going to want you to think about how to apply these services from an IT to business delivery standpoint, which I totally agree with. But just know that I'm going to present this to you, but I might not go very deep on it unless you want me to. Yeah. Probably the best thing about this is it does actually ask you to think about how you're going to explain these concepts to somebody else. So if someone comes to you and says, "Man, deploying EC2 virtual machines is really hard. Isn't there a way to make this easier? Is there like a wizard or something that we could use?" And the answer, of course, is like, yeah, you could use EC2 for that. I'm sorry, you could use Elastic Beanstalk for that if you wanted to. Well, what if we wanted to deploy infrastructure as code? It's like, oh, well, there's a great thing for that. You could use CloudFormation, and that's just AWS specific. You could go outside to the industry to things like Terraform, Pulumi, stuff like that, which I will also bring up to you. So that's one cool thing about it, is it does force you to think about how to explain it to others. Here's our general path, which you are not required to learn, but this is how this is going to be presented, is every module is going to frame itself up into an overall context. Note that there's probably about 2 labs a day that we're going to cover. So we're going to talk about the fundamentals of architecting, and we do actually have a lab that's going to have us exploring, like using the AWS API to deploy some EC2 instances so you can get a feel for what that's like. That's going to be our first module. Second, we're going to talk about account security, because the first thing that we always ask somebody is what? What's the first thing we ask somebody when they're saying like, hey, we got a whole new website or we got a brand new service? What's the first question we ask them? Kyle, that's actually a better question. Mark, that's also a better question. Right? Yeah, like, is it secure? But usually the first question we ask them is that, okay, so how do I get access to it? Right? Which is a security question, right? But how do I get access to it? Right? Um, how do I test it? How do I get, how do I log in? What's my login? Right? So account security is going to be part of this whole question, because it's like, how do I get logged into this thing called AWS? Hopefully all of you have a free account. You don't need it for this class. We're not going to be using anybody's accounts but the lab accounts, which are going to rotate for every lab. So they're going to start up for every lab, close for every lab, right? So just know you don't need one, but if you want to get serious about AWS, you got to manage your own account, because it's going to teach you things that you may not get access to in an enterprise, which are going to help you with the enterprise. But the enterprise isn't going to give you access to billing, for example, right? But you got your own account. You can control that. I usually don't spend more than $5 a month on my account. Sometimes it's 20. That's my demo account. I've got other accounts that I spend more money in. But if you don't have your own AWS account, you want to get one and learn how to set budgets in it, how to set limits, and how to shut down resources consistently. Because remember, everything you do in AWS is typically going to have a billing impact or a security impact, sometimes both. So account security is going to be the second thing we talk about. Third is going to be networking, core networking, and you are going to have to understand this if you're going to run anything with a network card. So if you want to run a virtual machine, you're going to have to know how this functions. And also, just to say this, containers require virtual machines to run unless you do it in serverless mode. But even then, there's caveats for serverless mode. So, and then Lambda, which is serverless, right? The highest level of abstraction that you can get for hosting applications. So virtual machines have a NIC. Containers require virtual machines to run, whether you manage them or AWS manages them. And then there's serverless, which serverless, the servers are completely abstracted away. But just so we're clear, your serverless functions can actually run inside of a network. You can attach a network card to them. So understanding the fundamentals of networking is going to be absolutely essential. You cannot get away from it, even in today's day and age. And we are moving more from IP version 4 to IP version 6. So while this isn't a networking class, just know that you're probably going to want to take some time at some point to just buff up on IPv6, forget about it like most of us do, and then at least you'll know enough to navigate the basics, right? I know that sounds weird, but unless you're a network engineer, you're going to learn all that stuff and you're not going to use it, and so you're going to forget about 80% of it. But the 20% you retain is going to be incredibly useful. And then we're going to start talking about virtual machines. So compute services, golden images, of varying types, which is what AMIs are. We're going to talk about placement groups, like how to do high performance computing. And we're going to talk about EC2 licensing and all the other kind of subtleties of EC2, because how you use EC2, today, just to say this, virtual machines are the roughest way to use cloud, right? Still effective and efficient, a lot of control, but if you don't know the pricing options and how to like auto scale, then you're probably going to use AWS's expensive data center 2.0. This is a world of dynamic resources, not static. So, however you're using the cloud is totally appropriate. You're going to get efficiencies, but if you want to be better at it, then you're going to want to learn all these little distinctions around EC2 itself. Then we're going to move on and talk about things storage. And we're going to talk about block storage, which is stuff we share with operating systems. And we're going to talk about object storage, which is like an FTP server, but in this case, it's called S3, and it's not really an FTP server. It's API-driven storage. We also call that object storage. And we'll talk about shared file systems, like there's EFS and there's another product called FSX. These are products that allow you to either share NFS with Linux or CIFS or SMB with Windows. So it allows you to connect to thousands or hundreds of systems simultaneously with the same file system. And as we navigate more into day 2, we're going to talk about database services. There's going to be a lab. We're going to talk about monitoring and scaling, right? Which is going to be about configuring high availability. And then we're going to talk about automation, which I got to tell you, nowadays, with a completely API-driven infrastructure, automation is king. So if you're not using Terraform, Pulumi, CloudFormation, whatever it is that you want to use to create your infrastructure as code, and automate this with a build server, whether it's GitLab, Jenkins, ServiceNow, doesn't matter to me. I'm not attached to it, right? But this is how infrastructure is done now. We are not logging into the console and pointing and clicking unless we need to verify or troubleshoot something. That's it. And then we're going to talk about containers, which is that second level of application hosting. And we're going to talk about the two services, ECS and EKS, that they have, including some visibility options. And then we're going to talk about how to get core networking to peer together. And we're going to talk about how to connect some of the stuff that's outside of core networking in AWS. How do we route that around? Because there's some really cool options for that. And then last is serverless, which is that highest level of application hosting and abstraction. We're definitely going to talk about that. And then we're going to talk about edge services. So we're going to go from core all the way out to the edge. This will be things like, how do I firewall and protect and defend network traffic before it even hits my core network? How do we do that, right? And then how do we get Amazon's hardware in our data centers? So you may not know this, but you can now actually get Amazon to ship hardware to you. They'll install it, put it in your data center, and you can manage it from the AWS cloud, but it's their hardware in your data center. And then last but not least is backup and recovery, which figures really strongly on the exam. And we're going to talk about, they now call it the data center migration service, but they used to call it Cloud Endure. It actually just got renamed because reInvent was just like 2 weeks ago, which is their big honking conference. So we're going to talk about AWS backup as a service. We're going to talk about some recovery strategies, and that's it. So, and then last but not least, what you're really going to like is that you're going to build a multi-tier architecture based on the business specifications we've been talking about. And you can either just take the step-by-step recipes and solutions, or you can take some of the challenges on, right? So just know that you can turn the dial on how hard you want it. You can do it easy, or you can do hard mode. It's just up to you. Okay. Now this last one, as far as like the capstone project that we're going to do on the last day, this is the one where we're going to give a scenario with project specifications. You're going to take a look at it, and you're going to basically design the architecture in a lab. And I'm not necessarily going to guide you on that. I might tweak you, but for the most part, you've actually got the answers for reference, and you're just going to figure out how to implement what they're asking you for. A lot of people don't necessarily go hard mode on that, but I'm just letting you know it's always an option. Questions about our agenda of any type. What do you think of this? Is this where we want to head? Is there something that you expected to see here that you didn't? Like code services, for example? Okay. Okay. You ideally, yeah, Ryan. So to answer that, yeah. So yes, would code services be a part of the developer track versus the architect track? They are. They are more likely to be part of the developer track. So code pipeline, code build, code artifact, code commit, code guru, code star, right? I feel like I'm missing one. There's a bunch. Those are all part of the developing on AWS class. So you should have gotten an email, and it should have been, if I remember correctly, no reply at gilmore.ca. You might want to search your corporate inbox for that. You should have gotten invited with a license code to get access to a bunch of like student and lab guides. You are not going to need those for this class, but they are yours, and I checked to make sure they were available for a year. But you have access to the entire slide set that I'm going to talk to you about. It's all actually in that digital guide. So just know that you are going to get that license code in email. You should already have it. You just go to the VitalSource site that's in that link, create an account, submit and redeem your license code, and all of a sudden you'll have this digital footprint. The number one question I get is that, hey, can we download that as a PDF? No, but you can print it as a PDF. AWS's official stance is they do not provide a digital copy, but I know many souls who just print it out as a PDF and go from there. Okay? Okay. Oh, totally worth mentioning, because this is like brand new since the last like month or so, is that there is an online course supplement that's now available. It's in a website called AWS Skill Builder. Let me pull that up for you really quick so that way I can post the link. All right, so if we go to AWS Skill Builder and we get all logged in. Oh, no, that's a Cloud Guru. Not interested. This is a relatively new site, by the way, for them. So kind of funny. So I'm already logged in. Otherwise, it would have asked me to log in with an AWS account. You might need to create a login if you don't have one. Typically, if you had to log into the AWS.training site, you already have a login, right? So just FYI. If we go here, and here's the Architecting on AWS course supplement. I'll actually just post this out so you can all have it. The cool thing about the Architecting on AWS course supplement is that the answers to the capstone lab are actually in the back of this. So just be aware is that when we get to the capstone lab, like lab hints and lab instructions, if you're looking for these, they're actually at the bottom for this, like not task 3, task 4, but like this very last one. So just know that if you need to get access to the like capstone lab, you can get access to it here if you want all the step-by-step instructions. It's a little different than what we're going to be doing for the rest of the labs, where you're going to be given all the instructions right there on the lab environment. This one, you actually have to go to Skill Builder on the very last day, the very last lab. You're going to have to come here and get all the lab instructions. Okay. Otherwise, all the stuff we talked about, fundamentals, account security, networking, it's all right here. Now, you might say, well, then why am I taking a class with you, Michael? It's presented a little differently here. Some of it, goes a little bit more in depth and has different links, but you're going to want to use this as a supplement. That's why it's here as a supplement, not as the core class. Okay. All right. Posted that link in chat, so you should definitely have access to it. Okay. And the labs. We're going to do deploying APIs. We're going to set up the networking infrastructure. You're going to create a database layer and add that in. You're going to create high availability, so do some duplication. You're going to build a serverless architecture using Lambda You're going to configure a CloudFront distribution to distribute our edge network out. And then your multi-tier architecture is going to include all of this and more as part of your final kind of lab. Okay. So stakeholder feedback, some user stories, some solutions, some review. Yeah, just let me know. Okay. Any questions at all before we roll into module 1? All right then. Excellent. Okay, let's get it. Oh, you know what? Probably a good reminder, right? Let's see. This is architecting fundamentals. So one thing I will just make sure is I want to make sure your labs are pre-warmed really quick. So just bear with me. Pre-warm. Yeah, there we go. Perfect. So always try to make sure that your labs are set up for you so that when you get there, you don't have to wait for them to provision. That can be kind of annoying. Okay, so we're going to take the next 45 minutes to talk about this little piece, which is just some fundamentals of architecture. Okay, so here's a question for all of you. Your companies, are they way into cloud? Are you guys deploying multiple, like you do everything in cloud? Do you have some production workloads and some in your data center? You've got proof of concepts, or you're like, we're just getting started, so we don't really have a whole lot. Where are you at, A, B, C, or D in your journeys here? Okay, just getting started, Calvin. Good. Got production workloads, Mark, see that? Oh, Calvin, you meant D. You run 100% in cloud. Okay, good. George, okay, so production workloads. Ryan, all in. A to C, we're just getting started, but data centers and cloud for many workloads. Okay. Okay, good. Excellent. Okay, good to know. So doesn't sound like anybody's actually an A. So people aren't just getting started or prototypes running. People are either C's or D's, if I saw that. And I know, Kyle, you were kind of in a hybrid space, but okay. Excellent. So then let's talk about some architecting fundamentals then. All right, so our CTO is like, hey, you know, our teams really have to understand the big picture because we're just getting started in our journey. We want to understand how to protect our resources, and also we want to make sure that we know how to architect properly, right, for clouds. This is where we're headed. So what do we need to be aware of before we dive any deeper? Because we're just getting our toe in the water, right? So objectives, really the questions that we're trying to answer with this module is, how is AWS's global structure organized? How can I control access to cloud resources? Who or what will control where our services and resources are going to run? And how can we build our cloud infrastructure according to best practices? Those are keys, I would say. Here, we like to shock you right off the bat. Ta-ta-ta! Here's a huge, complicated infrastructure. Now, I mean, obviously not the most complicated that anybody's seen, but still, so if we go over to the left and we take a look at CloudFront, Route 53, everything else that's listed there. Do I have it? Oh, hold on. I might actually have some drawing tools, right? So here we've got CloudFront, and then we've got Route 53. So this is the edge, and then we start moving in network-wise into our internet gateway, which is set up into a network. Little VPC here. Don't worry, all this is going to get explained, so just let it roll over your brain for a second. And then we're running in some availability zones over here, down here, and down here. And these are actually discrete data centers, or clusters of data centers. But these virtual machines that are listed here as app servers over here, and these RDS databases, they are running with network cards. They are in a data center. And notice there's a data subnet, there's an app subnet, and a public subnet. and each of these serves a different function. And each data center, so there's a discrete data center set over here, and there's a discrete data center down here. Each of these is kind of like the traffic's being like paired between them, mainly because of this load balancer right here. The app servers are hitting these caching servers, which in turn are talking and caching from these database servers. There's also a file system here that's being presented across both sets of data centers back to these two app servers. So there's a bunch of stuff going on here, and by the time we get to the end, we're going to build this one piece at a time. You're going to know what all these components are in AWS. I promise you. We will have talked about it so much that you're going to be like, oh yeah, I know what a NAT gateway is. It's used for natting. And I know why it's sitting on the public subnet, right? You're going to know what EFS is, and you're going to know why it actually runs across two availability zones across an entire VPC inside an entire region. You're going to know why that is. So that's our goal here, is to make sure that you understand this drawing to a certain extent. Now I got to get back to my pointer here. All right, there we go. Hold on. Normal non-drawing mode. Okay, so we're going to do some AWS services, talk about infrastructure, talk about the well-architected framework. The well-architected framework, by the way, is a filtering function that allows you to determine whether or not you're using cloud to the best of its ability, right? As far as resiliency, security, whatnot. It goes really deep. Just using it at a superficial level is actually still very valuable. So which services should we then look at if this is like our consideration, right? So what do we adopt? What are the service categories? How do we build services? What's the difference between managed and unmanaged? And then what about the services that don't really have servers for us to manage? Because if you hear the words serverless, you should think hidden servers. Because somebody's running servers, it's just not you. We are still using operating systems in 2021, but they might be hidden from you, right? So we're still using the old hardware operating system model. And while we are abstracting that away, it's not going to change anytime soon. Okay. Thus begins the journey. All these funky little dots that are on the map that you're looking at right now are Amazon's, AWS's data centers. Now, you probably saw them in the news recently because, they had an outage, a global outage, which is probably the first one they've had in a couple years, actually. At least the one as far as like impactful in my services. I can't remember when the last one was. Maybe 2018, maybe 2019. It's been a minute. It's unusual for them to have a global interruption of services, right? Yeah. So, and cool thing about like everybody else being down is that while you're still scrambling to get your stuff up, at some point in time you realize that it's out of your hands, and people start thinking about multi-cloud and stuff like that at that point in time. That has its own cost to it. So think about all these little dots on here, right? As like these are Amazon regional locations. This is where they have a massive investment in infrastructure, meaning they have multiple buildings, there's high-speed interconnects, there's independent power, there's physical security. These are locations where Amazon has invested heavily and making sure that things are available. By the way, the big purple dots are ones that haven't been released yet. So like Spain hasn't been released yet. Oh God, was it Melbourne? I can't remember now. One of the two in Australia is not available yet. Hyderabad is not available yet. Mumbai is in India. So a couple of these, the big purple ones, haven't been released or open to the public yet. But the rest of these, as far as like everything from Japan to South America to Africa to the U.S., the Americas, right, to Europe, those are all open and up and have been up in many cases since 2006. So there's about 200 services here. So, Amazon, I could argue, is first and foremost a security company, right? They have to defend every day against people trying to get your data that they're hosting, right? And then you pay as you go. So this is utility computing at its finest, right? You either pay for the capacity that you asked for because you asked for a 4-processor 16 gig virtual machine, or you pay because you asked for something to run every 5 milliseconds and you asked it for it to run, for 10 milliseconds. Go figure it out from there. So customers move to AWS because, quite frankly, for most of us, they actually do infrastructure better. Now, better is a very loose definition. So, if you need more control and you have tighter security requirements and Amazon doesn't meet your definitions, then that's not better, actually. Because cloud isn't a panacea. No, nothing is, right? It really depends on your business requirements. In general, though, the reason that they're at $54 billion annually, right, of revenue is because they tend to operationalize easier. There's less operational overhead. They can, you can use their hardware boundaries so you don't have to sit there and wait for hardware ordering. It really offsets a lot of operational and management complexity. And since they have a whole team dedicated to patching these services that you're using, typically you can minimize security vulnerabilities if you can accept them having the onus of security ownership for those pieces, right? And just to say this, I don't know of a single business that I have consulted with who started after 2012 that isn't all into cloud. They're not running their own data centers anymore. I can only think of one, and that's because they had really stringent security requirements that AWS couldn't meet. And that's it. Everybody's using cloud now. This is a, $54 billion industry. I'm sorry, not an industry, just for them alone. It's $54 billion a year, on projected target. So I don't even know what the market cap is on this particular industry because everyone's going in this direction. So even with the outage, and I got to say that when this first came out in 2006, we were all like, "There's no way we're going to use this. This is not going to happen. We're not using someone else to host our stuff. We already have a lot of third-party contracts with people's data centers and access to racks and da 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 da." And then just to say this, 4 years later, Gartner predicted security would be the biggest objection. AWS got their stuff together, got almost every security certification under the sun, and then our customers started asking for it, and so we started pivoting, right? And that's the way it went. So service category wise, just know that we're not going to talk about augmented reality, robotics, blockchain, quantum tech, media transfer technologies, code stuff, IoT. We're not talking about any of that. We are literally just going to talk about all the stuff relevant for hosting applications the way we've been traditionally doing it. So taking your Java app and running it on an operating system, taking your Java app and running it in a container, taking your Java app as an example and running it inside of a serverless environment where it just gets executed, you don't manage the servers. Now, I just use Java. I don't care what the language is. Java's not my language. Either Python, Go, or Rust would be the things that I would look at. But if it's .NET, that's fine too, right? C#, didn't matter. The point being is that we are only going to stick with core services that have to do with application hosting. We're not going over fringe, edge cases or even kind of like core edge cases like IoT and machine learning, right? We're not doing that. So typically in that context, architecture responsibilities is really actually to, I think research is a big part of an architect's, like what technologies are emerging, how can they solve business needs faster, quicker, and how can they solve operational needs like faster, quicker? Not just operational needs, but what about developer experience? What about testing experiences? What about security experiences? What about, there's this whole thing where enterprise architects in particular have a responsibility to make sure that everybody who's under the auspices of the enterprise are taken care of and the business itself, right? It's a really tough job, oddly enough. And so the job is to not just research, but also to plan, run proof of concepts, and then build in partnership with all these teams that you're affecting with their feedback cycles. And that's really what an AWS architect does, is plans, researches, builds, right? That's the function we're looking for a solutions architect in particular, not even necessarily an enterprise architect. So this sample infrastructure that we're looking at, this is going to be kind of our end game. Oops, didn't mean to do that. This is going to be our end game. This is going to be the thing at the end that we're looking for. We've got to know what services are available, how they interconnect, because this is what a solutions architect does. A solutions architect lives at the integration layer. This is not a software architect or an infrastructure architect who's building systems, right, and applications and has its own integration layers. This isn't an enterprise architect who's kind of looking at the higher level and figuring out how these pieces play out on a global scale. A solutions architect needs to know how services integrate with each other. How do they talk? How do they work? How do we get them optimized? How do we flow through a series of services? And then how do we take care of the security concerns and the operational concerns in conjunction with partnerships with those like groups or people? So this is what we're going to be targeting. Now, when you want to use AWS, there's 3 ways to do it. You can use the Web Console, which is a product that connects to the API. You can use the command line interface, which is a product that connects to the API, or you can use like software development kits, CloudFormation, CDK, which are all products that connect to the API. So hopefully you picked it up. What's the core thing that everybody connects to when they want to use any one of these products? Beach balled it up there. It's a softball. That's right. APIs. So, everything in AWS, this is software-defined infrastructure. This is what made this different in 2006, 7, 8. This is what made this different. Because the only body who was offering API-defined infrastructure was Heroku, and all they were offering was application hosting at the time. Then all of a sudden Amazon came out, and then Microsoft, and then Google right after them, and basically said, look, if you can verify who you are with a credit card and a phone number, we'll let you run 1,900 servers in 15 minutes. 0 to 15 minutes, you can get 1,900 servers in a single data center all stood up, ready to go and replicated, right? All within minutes. That was a big deal. So this kind of software-defined infrastructure, from both infrastructure as a service to platform as a service, right, to software as a service, that was a huge change, right? Is that it was all API driven. Let's see, Calvin, the license code that you got from Gilmore, no reply at gilmore.ca, will give you access to these slides, including, I think there's some notes in there, some speaker notes. I probably should use those, but I don't. Yeah, so you can actually see what's in there. If you want, when we go over the exam prep today, I'll bring up Bookshelf so you can see it. But it's bookshelf.vitalsource.com or evantage.vitalsource.com, and it basically gives you a digital copy of this slide deck. Unfortunately, I can't share the PowerPoints with you because Amazon AWS would have me drawn and quartered. I signed a contract that said we wouldn't share PowerPoints. I don't know why. The PowerPoints are not super proprietary, but we can't share them. Just to say this, if you want to scale, you have to use 2 and 3. You are not going to scale using Management Console. I got hired for a large company, which I'm sure you can look on my LinkedIn profile and find out who that was, as their global architect for cloud and containers back in 2018, 2019. And man, when I walked in, so it's like, man, I walked in, I said, how are you guys provisioning? And they said, oh, this is what we do. Click, click, click. And I said, what's your number one problem? They said, man, we just can't get consistency on the deployment of our servers. We don't have repeatability. We're having trouble automating. I'm sitting there going, yeah, imagine that would be hard because you're, not doing anything repeatable there. You're just click, 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 click. So just know the Management Console is absolutely spectacular for troubleshooting, learning, just confirming, starting off one-off stuff. But when you want to scale, you're going to learn how to use the command line, or you're going to learn how to use CloudFormation or the CDK. Or Terraform. Just saying, it's a third-party provisioner made by HashiCorp. It's a great product. That's a good one as well. Let's see. Oh, Calvin. So I'm only seeing the textbook Architecting on AWS. Yeah, that's the same. Inside there should be the little slides actually with the commentary underneath them. They won't look like this though. Let me rephrase that. It'll look exactly like this, but they're going to present it as a little box, and then there's going to be text underneath it. So, Management Console, we're going to spend some time in here. Management Console is pretty straightforward. So, just a little web page that allows you to click around and do this, that, and the other. You can find every service in there. Almost everything you can do with the command line you can do with the console. There are a few things that you can only do through command line. So Just something to keep in mind. Unmanaged services versus managed services. So in addition to the 3 ways of connecting to AWS, which is the console, command line, and using a software development kit of some type, is that you can also understand is that when you choose services, figure out whether you want to go infrastructure as a service, which means you've got raw access to the operating system, which gives you a lot of control. But remember, if you can configure it or log into it, you have to secure it. Which means if you launch an OS, you have to patch it. You might think that's trivial because we all have solutions for that. But if you launch, I think about the other day, I saw that Heroku, as an example, runs 200,000 virtual machines a day. 200,000 virtual machines a day. That's ridiculous, actually. But that's their business. It's just a lot in terms of the number. If they're using managed services for that, meaning that they, instead of doing that, let's just say they're just launching a serverless option where the only thing you're doing is optimizing your application, that means all of that other stuff comes off the back of their list, right? They can fire and forget on backups. They can forget the operating system. Because we are moving to a world where the operating system is still there, but we really don't care about it anymore. Even Microsoft is seeing this more and more, where people are still kind of hooked in and tied into Windows from a client perspective. But what we're seeing is that investment in really small footprint Linuxes. Is that a thing? Or just Linuxes? Anyway, moving on. Really small footprint Linux, basically, that has a low attack vector, very few system libraries except what's necessary to run hardware. And these are the virtual machines we're launching now. They boot in 10 seconds, which is ridiculous because that's almost as fast as a container, or 30 seconds on the outlay. The other day I was booting one and it started up in 35 seconds or something. I was just like, really? That's crazy. And it had all the services running. I was logged into the thing with a full GUI within 35 seconds. I was like, man, that's impressive. If you can get away from having to operationalize all this and your security concerns and compliance will support this, this is what the private sector is doing in particular. This is why these companies are going fast, because they are using managed services for their data stores. They're using managed services for their application hosting, and they're getting away from having 20 people to run 5 applications because they're no longer having to manage infrastructure from end to end. They're letting Amazon do it. So in a completely serverless setup, for example, it says serverless services, for example, like Lambda, do not operate within a VPC infrastructure. They can, by the way, so that is true. By default, they don't, but you can put serverless inside of your infrastructure. But you just access the URL for an application by its trigger point. So you could literally just go in there and say, hey, trigger off this Java function that in response to me copying something to S3, I want you to take that, whatever that thing I uploaded, and maybe it's a video file, and I want you to transcode it into high definition, medium definition, and low definition, right? This is where things are headed, is that now people are running serverless options and there's no operating system in there. We're not managing operating systems anymore. We're getting away from that. Services, not servers, are where we're generally headed. Now, as a server guy, just to say this, I'm a little bit but what about, I love my flavors of Linux and da-da-da-da. Businesses don't care about that. Businesses care about whether or not they can achieve the outcome with the minimal amount of IT footprint and give the customers an amazing experience while not breaking the bank. So this is kind of the focus. It is totally worth mentioning that if you want to distinguish yourself, I don't know why we as an industry are adverse to this. Maybe it's because most of our internal documentation absolutely is horrible for companies. And maybe you're different, and I apologize. But every company I walk into is usually using Confluence or some kind of wiki, or they've got a file server with a repository of files. Stuff's just out of date, right? It's not kept up to date. You're not sure what's real and what's an illusion, or what was fiction versus what was nonfiction. Just to say this, AWS's documentation is not that, right? So if you haven't been there recently, and this is true, by the way, for almost any modern project that I've seen recently. Let's say we go out to if we go to docs.aws.amazonaws.com, if you actually go look at any of this, let's just say, for example, we wanted to go to EC2. We wanted to, well, they got Nitro enclaves. That's kind of interesting. Let's go for Linux instances. And you were like, I'm really kind of curious, right? And by the way, you could download this PDF. You can stick it in your Kindle reader if you want to. But let's say you're here and you want to search this guide, and you're like, I really hear there's this funky thing called dedicated instances, Michael, that you were talking about. Can you point me to this? And then you can come in here and you can kind of like look through the different like products and pieces and see if you can find it. Now, it looks like in this particular case, it failed me horribly. Dedicated instances. Do they not have dedicated instances? You know what? Let's go back to the documentation. Let's search for dedicated instances. Maybe I was in the wrong document. Huh. Wow, that was a horrible example. Let's try this. Reserved instances. Here I am singing the praises of, and could not find what I was looking for. Security, log files, revisions. All right, hold on. Maybe it's not the docs. Let's try this. AWS EC2 reserved instances. Probably just a bad search engine on their part, because I think actually I actually do search for most of it. Okay, so here's the lesson from that. Don't use their search. Use Google search, obviously, to find out. But like this is where you would find like different pieces of documentation either on their web pages or in the docs themselves, because there was a reference actually to the docs down here, right? So see where it says docs. So it is in the user guide. I'm not sure why it didn't come up in the search. Let's just assume that their search is horrible. Just use Google to search. But this is inside their documentation for EC2. And notice it was exactly where I was in before, but their search just didn't bring it up, which is horrible, actually. Okay. So just know that their documentation is spectacular. Be the person who reads the documentation, because that will round out your knowledge completely. So people are always like, should I get this book or that book? You can, or you can actually read the documentation that AWS has, because it's actually really good, and they do keep it up to date. By the way, if I gave you the impression that it was perfect, well, hopefully that illusion just got shattered with me fumbling around. All right. So that was just all like a brief skim of all AWS services. So brief skim of all AWS services. That's just a brief skim of AWS as a concept. The 3 ways to connect to it, understanding documentation, and the fact that we are really just going to focus on the core services related to application hosting. Any general questions about those broad strokes? Okay. Okay, so let's talk about the infrastructure. We're gonna do this for this in the well-architected framework for the next 25 minutes, and then we're gonna take a break. Okay. This is really simple and straightforward. So Amazon runs data centers. I know that's a shocker. You're like, what? Data centers? How do they do that? Oh, wait, we just had a huge outage. That was more about DNS. But regardless, they have data centers. They have servers in them. We run our virtual machines inside and on top of those physical servers, right? All proprietary networking equipment, all proprietary connections. These data centers are organized into what they call availability zones. Availability zones are then stuck together because they are like geographically near to each other. Those are called regions. I think an availability zone is at least, if I remember correctly, like 25 kilometers. I'm gonna have to look that up actually and find out. There's like a minimum distance that they maintain from each other. Sometimes that doesn't meet DR requirements, so you might have to look at multi-region at that point in time. But the devil's in the details, right? So, which is a weird phrase. The details matter. So you might need to look at the documentation for the AZ if you have some kind of like minimum DR requirement that you're trying to achieve. General rule of thumb, obviously with the exception of this last outage, is that if there's going to be a failure, it's typically going to be inside of an availability zone. It is super rare for Amazon to have a global outage like the one they just recently had. It really is, actually. So one thing to think about here is that when you run services like a web server, you're at a minimum going to run 2 web servers because you want one in one availability zone and you want one in another availability zone, and you're going to load balance traffic between them. Because if there's going to be like a minor hiccup or an outage, it's going to be along the lines of a single availability zone. Now, just to make sure this is clear, availability zones are actually clusters of data centers. So you can think of a region as a cluster of clusters, a meta cluster, if you will, because meta seems to be super popular now. Did everyone order an Oculus Rift for Christmas? If you don't know what I'm talking about, look up Meta, right? Facebook's new name. So these data centers are put in isolation and fault tolerance with each other. So an availability zone has its own independent power, independent cooling, and independent networking out to the internet and to the other like availability zones in the region. You're only going to see usually single millisecond, like single digits, excuse me, of latency between these availability zones. You might see a little bit more if someone's trying to crush Amazon's network, which does happen. But usually, I think at most I've ever seen is maybe 15 milliseconds of additional latency between it, and that was at a really kind of crushed period. Typically, it's single digits, right? That's not a guarantee, but that's typically what we see. So just know you're going to want to use at least 2 availability zones for any of your production applications. So at a minimum, you're going to run 2 servers, 2 containers. Don't worry about Lambda. Lambda operates at a regional level, so it doesn't function the same way as anything with a network card does. But every single region in the world, whether it's in Africa, Japan, Australia, has a minimum of 2 to 3 availability zones. Some have 4, one has 6. So AWS in general seems to be targeting 3 availability zones for all of its infrastructure for its regions. Okay. So that means inside every region, if it's in Spain, it's got 3 availability zones. If it's in Germany, it's got 3 availability zones. So 3 discrete interconnected sets of data centers that you can be assured have fault tolerance and failover for, right? Unless one of Amazon's global services has a problem, right? Like DNS as an example. So there are the regions. And by the way, Amazon has a GovCloud region west and east, which, for those of you who work for Booz, right? Is that, that's what you're using. If you're involved in government contracts with the US, you're going to be involved in GovCloud east and west. One word of caution, GovCloud does not always have the latest features that the private stuff does, right? Or I guess we would call it the public infrastructure, right? So just know that you want to check the service availability maps. In general, though, Amazon does a good job of making sure that once they release it to the general public, that it goes in the GovCloud within a couple months, right? So just know. Oh, I didn't know they were opening one in Sweden. That's new. Didn't even realize that was on the map. Huh. Weird. All right, Bahrain, the rest of it, this basically shows, what's either coming or what's already out there. These are regions. Each of these regions has at least 3 availability zones. One other thing to mention is that on every continent, there's usually one availability zone that's more expensive than the rest. So just so you know, most people don't use Northern California because it's about 10 to 20% more expensive for the exact same service that you would get in other regions. Tokyo used to be that way. I think they shifted that a little bit more. Frankfurt used to be that way in Europe. So just know you want to check the costing. Because while in general costs are somewhat similar in the continent that you're on, some of these data centers you don't want to use because they're going to be more expensive. So just use the next closest one. Now, obviously the number one factor for whether or not you're going to use a data center is whether or not you're allowed to. That's the number one factor. Second factor is it close to your users? Don't put web servers in Tokyo if all your users are in the United States. That doesn't make any sense, right? Service availability I just mentioned. If you go to, GovCloud and you're trying to use the service, and by the way, if you're using GovCloud, you probably have to use GovCloud. So here's a better example. If you're going to go into Mumbai, which may not have all the services yet because it's only like a year or 2 old, you might need to check the service availability map just to make sure it's there. If not, then you might default over to Jakarta or Bahrain or some other data center. And I mentioned cost as well, because remember, in every continent, there seems to be one of the regions that seems to be a little bit more expensive than the others. Amazon is trying to normalize that, but the problem is that sometimes power, land, cooling, all that is more expensive in that state compared to the other pieces of the country, right? So, yeah. So first rule, are you allowed to use the region in question? There are restrictions in every company. 2, is it close to your users? That's probably going to be the region you're going to use. 3, does it have the service that you need? And, to Kyle's point, are you allowed to use that service, right? And then 4 is, are you using the most expensive of the data centers that are there on that continent? Maybe check that just to make sure, because you might think it's not a big deal, but when your bill goes up by 10 or 20% and now you're spending, $120,000 instead of 100, just, be mindful of that. Yeah, so Calvin, the dictation is your company, right? Like, for example, if you are in relationship with the United States government, you're not going to be able to run anything in a data center that, is off of U.S. soil. And there's other restrictions like, citizenship status and all this other kind of junk that's there, right? You got to remember that. If you're operating something in the EU and they don't want citizens' data to leave unless you're willing to comply with all GDPR requirements, you might operate solely inside the EU just to make sure. GDPR doesn't require that, by the way. I'm just throwing that out there as potential use cases, is like you're trying to comply with the next level of like data compliance, right? Or like if you're working with the UAE, there's about to be a data center in the UAE because the UAE won't let you like house the data off site, right? The United Arab Emirates in the Middle East. So something to just be mindful of. Okay. Now, just to confuse you completely, not really. All right, so we got regions and they have availability zones inside of them. Now remember, availability zones are just clusters of data centers. Right? This is what we were just looking at, right? These are just clusters of data centers. These sit inside of regions, which is what these are. Now imagine if you had a data center, not a cluster of data centers, but you had a data center that was sitting outside of the region, but was close to a major metropolitan area, because your users in Boston are hardcore gamers and you need to make sure they have single-digit millisecond latency to your applications. And so Amazon came up with this concept called local zones, which said, what if we just took an availability zone and stuck it in a major city, but there's no backup? Meaning if that local zone fails, you have to fall back to a region, 1,000 miles away. So this is what they did. It's like in Los Angeles, Houston, Miami, Boston, Philadelphia. There were 4, and now there's like 15 of these. Amazon has stuck a data center, not a server, a data center in these like 20 major metropolitan areas, and you can run applications in these major metropolitan areas, and they do not have all services, by the way, just a small subset of services. And what happens is if you decide to run it in Boston because the city, the government of Boston is using your application, you want it to be as fast as possible. If that data center goes down, you have to fall back all the way to Virginia or Ohio. But Virginia is the fallback typically, right, for that local zone. So those local zones are just like, they're in a sense availability zones that are not coupled with the region. They're not in the region. And they are now set in major cities all across the eastern and western seaboard of the United States. So Amazon came up with this because people needed faster latency, like faster performance, right? Response time, not faster latency. They needed faster response times for their applications. So just know that they now have taken data centers and just put them out, but they are not as redundant and not as highly available as the availability zones that are inside of a region. So they really are used for like really high performance edge cases, but people are using them. The only services that really run there, by the way, are the core services that we're going to talk about. You're generally not going to find machine learning and other kind of services in these local zones, right? They're really only for application hosting. So just know that they exist. Most people don't even know about them. They came out in 2020. Amazon's been going gangbusters on them. So instead of launching a bunch of new regions in the United States, they've been launching these data centers instead. So they're just called local zones. Now, to make things, just take it to the next level, because we've got regions like Virginia and Ohio and like Oregon, and we've got California as an example. So we got 4 major regions in the United States. Each of those regions has at least 3 availability zones in it. So those are the clusters of data centers, but they're near West Virginia, they're near Ohio, they're near Oregon, they're near California, meaning they're in the actual state. In addition, we have local zones, which are really just availability zones that have been pulled out of the region. So we've got local zones in Boston, Miami, Texas. I can't remember, Houston, I think it is. Los Angeles, Philadelphia, like they're all over the place. So we've got these data centers now, but those are data centers. So we've got regions, which are collections of data centers. We've got local zones, which are just data centers with no associated region in each major metropolitan area. And then to drive caching the world over, Amazon has taken single servers or racks of servers, not data centers, just servers or racks of servers, and they've stuck them at where every major ISP is located. This is smart, by the way, and I think Netflix taught them how to do this. So they approached Comcast in Atlanta and said, basically, hey, can we put a rack of servers inside your data center? Comcast says, how much are you going to pay us? Amazon says, this much, whatever agreement they came to. And so now when I'm on my Xfinity Comcast connection and I need to get to an application that's on Amazon, I actually just go to the Atlanta Comcast Xfinity data center and I hit that rack of servers instead of going all the way back to Virginia. These are called edge locations. They are sprinkled like salt and pepper if you just threw it on a map. Everywhere there's a major internet service provider, this is where Amazon sticks a server or a rack of servers. When I say a server, it's a pretty big server, but it's a rack of servers, right? About 3 weeks ago, I actually had somebody from AWS in one of my classes who was an installer for these POP or edge locations. And he was like, yeah, he said, I can't talk about it a whole lot, but he's like, yeah, we install racks of servers generally inside every major ISP. So doesn't matter if it's in South America, doesn't matter if it's in Africa. If there is a major internet service provider there, and I don't know what their thresholds are, they have a rack of servers in there that's actually serving out that populace. And so this is where you can actually cache content and serve it out to your users. This supports things like CloudFront, which is a huge service for this, Lambda at the edge, Route 53. It says major cities, but it's really actually about ISPs. So if there's a major congregation of people, this is where they're going to run a rack of servers. So we've got 4 different locations, right? We've got regions, which are comprised of availability zones. We've got local zones, which are really just availability zones that are not inside of a region. And then we've got these scattering of edge servers, which are scattered all over the globe, right? So you've got, and there's actually 2 more like other locations, but those are like for wireless and stuff like that, which we don't use, like 5G. Not for application hosting. We're not even going to talk about that. Okay. Do note, by the way, that in the map that you're looking at right now, it does say that the region itself has some edge caches inside of it. So just because there's servers scattered all over the world for CloudFront doesn't mean that CloudFront also doesn't have a presence inside the actual regional data centers themselves. So just remember, services in AWS operate at an availability zone level or local zone level. They operate at a regional level, which means they use all 3 availability zones that are inside of a region, or they operate at a global level, and that would be things that use like edge locations and whatnot across the entire world, right? So remember, services either function at a global level, a regional level, or what could be called a data center or availability zone level, which includes local zones. If you're running a virtual machine, by the way, question for you all, and it has a network card, is it operating at an availability zone level, a regional level, or a global level? When you run a virtual machine, where does it live? That's right. If DNS, the domain name service, has to feed out name resolution for the entire world, is that a global service, a regional service, or is that an AZ service? Right. It's global, right? That's why, by the way, when Amazon had problems with their DNS service, everybody had problems, right? If you decide that you are going to serve out a DynamoDB table and it only functions in Virginia, right? All of Virginia, is that a global service? Is that a regional service? Or is that an AZ service? Good. That's a regional service, right? Meaning you have started a DynamoDB database table inside of Virginia, but I didn't say an availability zone. I just said Virginia, right? If I said Oregon, same thing. So just know that there are services that operate at a regional level, and they completely withstand availability zone failures because they operate across all the data centers that are inside of a region. Okay, here's the last question. What is the name of the physical location if someone comes to you and says, I need single millisecond latency and I am in Houston and I want you to run my application as close to my users as possible? Which of these 4 locations are you going to use? Let's be specific. Local zones. Local zones. So good. Perfect. If someone comes back to you and says, I have a website in Virginia and I want to make it as fast as possible for the entire world and I do not want to run in multiple regions, which service are you going to use? Which of these 4 locations are you going to use? I'm going to lean on Calvin a little bit since he kind of answered it on the last one. It's the edge locations, right? You're going to use the edge locations. The edge locations are going to make that single website. It's going to create a cached copy using CloudFront. It's going to make it available the entire world over, okay? We're going to talk more about that because these concepts may not be sinking in just yet. It's totally fine. But just know, AZs exist inside of regions, local zones exist outside of regions, and edge locations exist outside of regions as well. The difference is that local zones are data centers. Edge locations are either a server or a rack of servers, right? Okay. By the way, just to drive home the edge case kind of thing. So over here, we've got a customer over here. And this customer, let's say this customer is, I don't know, in China. And this customer wants to come all the way back here to S3 in Brazil. So this customer, though, is going to have a horribly latent experience. So what will happen is that when they go to talk to this server, DNS is going to redirect them to one of Amazon's closest edge servers. And then what will happen is that instead of running over the internet, which could be slightly slower due to internet weather, this little arrow down here, this is Amazon running off of Amazon's high-speed backbone. This edge location is going to go retrieve this video file, cache it at the edge location for as long as you have told it to cache. And then not just for the first customer, but for the second, third, fourth, and fifth customers that are in China, it's going to feed that video file from this edge location instead of going all the way back to Brazil to get it. This, by the way, happens the world over. These caching servers will cache this video file, and if a user is closer to the edge servers, the user will automatically get redirected to the edge server. The edge server will grab a cached copy, and the second, third, fourth, whatever thousandth user in that region that tries to get access to that Brazilian video file, they're going to have a cached copy instead. They're going to access. So this is how like CloudFront works as an example. This is where we're using edge locations, right, to drive content closer to the users so that we don't have to have them go all the way back to another continent to get their information, files, videos, whatever. So just remember, local zones are ideally for application hosting for low latency. Edge locations do not host applications, they cache content. So if you want to drive data processing closer to your users, you have to use a local zone, which again is an entire data center. Edge locations are really just for caching, although you can execute some data functions inside of an edge location, but not nearly the amount that you can do in a local zone. Local zones are going to have a really great like hosting capacity. Edge locations are going to have a really great caching capacity. All right. This is a good time for us to take a break, but before we do that, does anyone have any questions? We won't lose any time if anybody asks any questions, by the way. We're still going to have our 15-minute break. Okay. All right, let's do this. So let's say it's 10:56 right now. So 15 minutes would put us at what? 11:11. That sounds good. Let's do 11:11. So come back at 11:11. So 11 minutes after the top of the hour, and we're going to continue our discussion about the well-architected framework, and then we're going to dive into a lab so you can get hands-on. Okay. So go take your time, step away, come back at 11:11. We'll go from that point in time. All right. We'll see you in a bit. Okay, how about now? Can you hear me now?
Yep.
Cool. Okay. Whew, so interesting. All right, let's cover this last little piece, but before we do that, does anyone have any questions about the 3 ways of accessing Amazon, the core services that in general we're going to cover, anything about regions, availability zones, local zones, or edge locations? Okay, let's get it. So, well-architected framework. So, what you need to know is that there's actually now 6 pillars to the well-architected framework. They just added sustainability in like the reInvent thing that was two weeks ago, the conference. So security, cost optimization, reliability, performance efficiency, and operational excellence are all now like part of the well-architected framework. So there's a tool actually that actually asks you questions about your workload to find out if you are aligning with the well-architected framework. It is actually not like a scanning tool. It's just a bunch of questions that you ask. And it's supposed to get you to think about these kind of things. How are we going to recover from failure? What are your recovery procedures? How are you using resources cost effectively? Monitoring, infrastructure as code, principles of least privilege, stuff like that. Like it asks you questions about how like your workload or your account is set up to see if, you can get it set up in like a cloud native way, right? So there is the tool. It basically is going to ask you questions about our workload. It's going to review your architecture. It's going to ask you questions. You can create a high risk plan. Sorry, you can create a plan to fix any high risk issues. So it's useful. It is useful as a filtering function to find out if your workload is even leaning in the right direction for cloud. So this is not a migration tool, by the way. There's other cloud adoption frameworks and migration checklists. This is really for things that are already running in cloud. Are you adhering to the ILITs, right, in the right way? Obviously for your workload. Okay? So just know that this exists. And just to be clear, there are white papers for every one of these. There are research papers for all of these. So you can find them under the AWS white paper section, and you can find the deep dives into cost optimization and reliability. It is rich, it is deep, can be overwhelming, but very useful. Okay. All right, knowledge check. So which of these infrastructure as code automation platforms is going to deploy resources at scale? In other words, which of these is best for automation? That's a better question, actually. Which of these is best for automation? So I got to tell you that all of them are actually remarkably good for automation. And the CDK actually does convert things into CloudFormation. But CloudFormation is the actual service. So the question's a little misleading because what it should say is, which of these is an AWS service that deploys resources at scale and is actually an automation service? It should be a better question there, right? But CloudFormation is the infrastructure as code service inside of AWS. All of these other preceding like facets, the CLI, CDK, SDK, can talk to CloudFormation. Okay, which of the following are clusters of data centers within a geographic location with a low latency network connectivity between them? What are those called? Yeah, so availability zones, right, are clusters of data centers, right? So in this particular case, a cluster of clusters is a region. A cluster of data centers is actually just an availability zone, something we pointed out. All right. Which of the factors, like which of these do you consider when you want to pick an AWS region? Right? What are the most important ones? Now, I'll tell you right now, one thing that's missing is cost and service availability. What are the other two that are here that are considerations you want to think of when you actually are deciding on which region you're going to run your services in? Good. Good, Kyle. Yeah, that's correct. So any security compliances or regulations or whatever limits, legal limits you have, so local data regulations, and then any latency to end users. So A and C are going to be your friends here. All right, so then what's the primary benefit of deploying your applications into multiple availability zones? What did I say that would get you? That Amazon says this is a best practice. Put a web server in availability zone A in Virginia and then in B in Virginia. Why would you do that? What do you get by doing that? You don't get stronger security policies. You're not going to get decreased latency to resources, right? But you'll definitely get high availability, and there's definitely benefit to the design, right? So high availability is really the key. Is that way, if you lose a data center, you got the other one to fall back to. Like active, right? Not active, passive. Okay. The principle of least privilege is a principle under which of the well-architected framework pillars? So just think about what that's about, right? And you can easily figure out which of the pillars it's about. Least privilege always relates to what? Good. Response is there, right? It relates to security, right? Give the user the minimum amount of privileges for the task that they are asking to do, and preferably verified by a higher authority, right? The user comes to you and says, hey, I need access to this database in order to make changes to it. And you're like, okay, I need authorization. Like, get somebody who can tell me that you are supposed to have this access, right? That's the end of module 1. Okay, so let's get hands-on. So we're going to take the next 30 to 45 minutes to actually work on a lab. Oh wait, it's right here. Hold on. Don't go anywhere yet. So we're going to use the AWS API to deploy an EC2 instance. So in this particular case, you're going to have a couple of things created for you. And what's going to happen is that we're going to create an EC2 instance using the console. We're going to create an EC2 instance using the command line. And we're going to create an EC2 instance using a CloudFormation template. So you're literally going to see the 3 ways that you can create an EC2 instance. And then you're going to examine and run a second CloudFormation template as an optional task. Where are we going to do this at? Well, this is going to be pretty straightforward. So we're going to go to a URL called webage.quicklabs.com. This is going to be the location where you are going to run all of your labs for the remainder of this class. What you're going to do is once you get logged in, and by the way, you already have a login created for you. What's the login? Well, the login is going to be the email address that you use to register for the class. And so let's go take a look at it. So for all of you, and I'm sorry, I'm going to share your email addresses out, right? Here's Hotmail, BAH, Shelter Insurance, Permit Company, BAH. So just know that this is the login, right? If you don't know what your password is, and you should have gotten a link already sent to your email address, just click on Forgot Password. Type in this email address, and then that will allow you to get a reset link sent to your email address, okay? The lab that we're going to do, so once you get logged into webage.quicklabs.com, you're going to click on My Learnings, and you're going to see the Architecting on AWS class listed right there. Once you then get into this kind of like viewpoint, which I know this is pretty big, so actually I'm going to blow this up. What's going to happen is, hi, are you still pre-warmed? Yeah, you're still pre-warmed. Is you're going to open up the lab. Your labs have already been pre-warmed for you, which means I actually did the provisioning for you while we were talking. You're going to come in here, you're going to click on Start Lab. When you click on Start Lab, it's going to switch over and you're going to see all this information on the left-hand side, but you're going to keep this tab open, which is why we recommend that you have 2 monitors or a laptop and a monitor for this, okay? And what's going to happen is that you're going to click on Open Console, and actually, let me make this a lot easier for you. You're actually just going to go down here and you're going to follow the directions. Start lab, which I already did. You're going to open console, right? Which is going to take you here. You're going to copy AWS student. Actually, I just did that wrong. You're going to copy the username, place it up here. You're going to copy the password. It's going to take you here. You're going to copy the account number. You're going to place the account number here. And so you're going to use that information to log in based on the fact that you clicked on Open Console. Once you get logged in, you should see in the upper right-hand side, no, not LastPass, you're going to see AWS student up there. AWS student at some account number. If you see that, then you're logged into the right place. If you see something else, then you need to click on sign out. Okay? And then from here, all this other information, like for example, the fact that you're in US East 1, please, please, please make sure that this says North Virginia at all times. If you switch to another region, which sometimes the console does that, if you switch to another region, your resources, your lab's going to break and you're going to have to start over, right? And I don't want that because that's time we can't get back, right? So once you're in the management console, you are free to start the lab. Now, what you're going to do is you're going to create an Amazon instance using the console. Then you're going to use the command line interface. Then you're going to use CloudFormation. And then you have an optional task to actually run another CloudFormation template. So all you need to do is just follow the directions starting from the minute you hit start to all these steps here. That's it. You're going to follow it down. I am not necessarily going to walk you through every single step. I am just here to support you if you get hung up on a step or if you run into a problem. So this is you navigating these instructions and that console on your own. So there's going to be a little bit of a learning curve because you're not going to be able to see stuff at first if you haven't spent a lot of time in the console. Okay? And so I know it says an hour and a half. They usually give you 2 to 3 times the time that you need. I'm going to check back in, right, at about 12:30. Actually, it'll be about 12:15 because that's when we're supposed to check back in. But about 30 or 45 minutes, I'm going to check back in, okay? So go ahead and get started on this lab. I am not going anywhere. I'm going to be right here, and I'll answer any questions you have. We'll do a little bit of a run at Module 2 before we take lunch at 12:30, but this is what we're going to be doing for the next 30 to 45 minutes, okay? So go for it. Let me know if you need anything. So George or Jorge, sorry, I don't know how to pronounce your name. So just to say this is that you should see a start lab button in the upper left-hand side. Oh, first of all, are you at webage.quicklabs.com, that link that I posted earlier? Okay. Yeah, so that link that I posted earlier, webage.quicklabs.com, that's where you want to go to get logged into the lab environment. Oh, sorry, that was my account number. Let's see. It was posted earlier in chat. Yeah, hold on. There we go. Perfect. Okay, so here we are. Let's check in really quick. Here's a question for you. I know some of you are like, I have no idea how many accounts we have. What do you think? I suspect that most of you probably have more than 10 accounts because, I mean, who has only 10 accounts who's been using cloud today? Since most of you were not getting started, is it true? Do most of you have more than 10 accounts? All right, here's a better question. You don't know? I don't either. I'm sure most of you don't. More than 10. That's what I suspect. Let me ask you a better question. How many of you have your own personal AWS account? Okay, good. Yeah, Kyle, actually, cool thing. If you start up Control Tower on one account, you can then just vend. You can like create multiple sub accounts that are all part of your organization. So, yeah, good deal. Okay, just curious. No right answer there, obviously. Okay, so let's talk about account security. So, we basically need to understand how to manage this, right? How do permissions work? We're also using Active Directory, and we've got over 50 AWS accounts, right? So, and how do we make sure they're compliant? When I walked into a certain unnamed company, right, there were 700 AWS accounts, and they were all individual. There was no organizations applied to them. Really kind of intense, actually. So, how do we solve that problem? So, what are the best practices to manage access to AWS accounts and resources? How do I follow the principle of least privilege? How do I grant temporary access to resources, which, by the way, figures very heavily on the exam? Amazon has a very particular perspective on the use of IAM roles, and it is for temporary access. You're going to hear me say that several times. And then how do you manage multiple accounts? You know, organizations, which gets activated if you use Control Tower, right, is also a great way to manage multiple accounts, and we'll talk about that a little bit. Okay. So account security solutions. All right. So with account security, right, we've got a couple of problems. And this is true for, I think, any system. One, how do we verify your identity? Two, once we've authenticated who you are, or at least who you represent, how do we figure out what you can do? How do we authorize you to do things, right? And so that's really kind of what we're looking for is like, how do we make it so that we can grant you permanent access after verifying your identity? And then how do we define that access? And then if I need to grant you temporary access, like we do with sudo or the Windows account elevation, how do we get you access to temporary security identities that have permissions assigned to them? Also, you can access resources and services. That's it. That's all we're doing. So here we're going to talk about security principles. How do we create repeatable processes to provide access for like a new development team? Well, what we need to talk about actually is the root user, which sits a little bit outside of the service called identity access management. And we need to talk about the three principles inside of IAM, namely users, groups, and roles. Now, the root user is the account that you use to create your AWS account. It's the one that looks like an email address. Do not use that account for anything after you've created an IAM user, because the only reason you should be using that is if there's an emergency, like you get locked out of your account, or if AWS tells you to, because that's how you need to do some kind of administrative function for AWS. The root user cannot be restricted in accounts that were created before like December 2017 or something like that. They can be restricted in an organization if the account was created after, like, I want to say it's Q3, Q4 of 2017. But if you create an account, if you use an account that was created before that time, that root user cannot be restricted in any way, shape, or form. So I've seen a company go out of business because they put their root user credentials inside of a repo for 10 years. Finally, in year 10, someone got ticked off and deleted their entire non-production environment, not even their production environment. The company was out of business in 6 months. And that's a sad little horror story. There were many other factors that put them out of business. But my point to that is that this has like damage associated risk with it, right? So use this account, scramble it, attach MFA to it, but use it to create an IAM user and then put it away. Don't use this user at all. Do not create access keys with this user. Do not create SSH keys with this user. Just don't use it for anything. Just that one thing of creating an IAM user and then move on. So then once you've put away your root account and you've created your first IAM user, which is usually an administrative user that has like full administrator access, potentially, right? Then what you're going to do is you're going to use that IAM user that you created to create the users, groups, and roles that you need, including the associated security policies, the access policies that go with those users, those groups, and those roles, right? And so this IAM service is where all the users and whatnot live. You can, by the way, analyze your access patterns, and you can federate IAM with a number of third parties like Active Directory, Okta, Ping Federated, Boards. You can use a lot of federation services. If it supports OIDC or SAML 2.0, you can federate it with IAM. And by the way, you could do web identity federation. So if you want to do Google or Facebook or Amazon, you could do that as well. Let me be very clear about IAM's use. This is not to log into operating systems. This is not to log into databases. This is not to log into Kubernetes. This is strictly for AWS access. Can you extend it to do those things? Sure, but it's not what it's designed for. This is not a service that's designed to host application users for your web application. It's not designed for that. IAM is simply to grant people access to AWS infrastructure. That's it. The three principal entities that you use are users, which are typically one-to-one to either an actual real person or in a user ID. Occasionally, it might be attached to an application or a service, but try to get away from that as much as possible. And then the other thing is that users are stuck into groups. And so both users and groups can have permissions policies attached to them. So a principal entity like a user or a group or even a role can have permissions attached to it. But typically what happens is users are stuck into groups. The groups have permissions. And then what happens is that users are added and removed from groups in order to grant permissions, right? You don't necessarily typically associate access policies directly with users unless it's an exception. Now, roles are a little different. Just to say this, is that roles are security identities that a user can assume. So for example, if you've got a regular user who has read-only access to an account, and all of a sudden you want that user to be able to modify EC2 instances, they can assume or elevate their privileges up to a role. That role could be EC2 admin, and then they can take that role and apply it and actually use the console or the command line to do their task, and then they de-elevate once they're done. This is no different than the Linux sudo command. It is no different. than the Windows administrative elevation, right? In addition, by the way, just to make this clear, is that there are actual services inside of AWS that are going to need permissions. They usually get those permissions through roles, because the service is already an authenticated identity, because Amazon knows what every single service is inside of its ecosystem. So users and services are typically authenticated identities. The cool thing is that services are automatically authenticated, because the minute you start one, AWS knows what it is, knows what account it's attached to, and knows exactly what it should be doing, right? Now, federated identities like Active Directory or other third-party identity brokers, like you can log into separate from IAM, those can also be federated with IAM. So you could log into Active Directory, and it's got a link to IAM, which allows you to log into Active Directory and get access to AWS resources. Now, just because you link in an identity broker with IAM does not mean that identity broker by default will grant any permissions to its users with IAM. You have to tell IAM what each group and user on Active Directory is able to do, right? You can blanket it, say that anybody who logs in has read-only access. That's a bad idea, by the way. But you can control that. So remember, there are basically three principal entities: users, roles, and groups. Amazon likes to list services as an authenticated identity. That technically is accurate, but it's not really a principal that you can create in IAM. And identity providers are also not an entity that you can create in IAM. It's really users, groups, and roles are the kind of like main principles inside of IAM. Now, users work exactly the way you think they do. I got an M Forrester user. It's in my account. If I want to elevate up, I got to take on a role called M Forrester admin, right? Notice that this is separate from the account root user, right? The account root user doesn't even really fall under IAM control. You can't apply policies to the root user. You can't really restrict the root user unless you're using organizations. But once you've created a user that has a username and a password to log into the console, that person can log into the console and do things based on what you've told IAM that user can do. So if they're a developer, but they have administrative access to a DynamoDB table, then they can do that, right? If they're an auditor with read-only access, then they can read things. So just know that by default, any principal you create in AWS has no permissions. A user has no access. A group grants no access. A role has no access. You have to specify it. Now, when you run the console, the CLI, or an SDK, you have to provide some means of authenticating who you are. There's actually two different ways to do that. If you're doing the management console, it's a username and password. If you're doing the CLI and the SDK, it's called an access key and a secret access key. And you can just think of that as a username and password. Access key, secret access key. Okay, so the access key says, hey, here's what, my identity. The secret access key says, here's my password, right? So two different ways to authenticate, depending on whether you're doing the command line or whether you're doing the web console. Now, I said command line. That included the SDK and Python and Java and Go and blah, 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 right? Now, look at these two permission sets. So these are policies, right? Think of this as policy. EC2 star means that any API call underneath the service EC2, those administrators can make. The other one says any describe API call, like describe instances or describe disk or whatever, right? The auditors can make. In other words, they can only look at stuff. They can't really change anything. Now, there's more to a policy than that, but you get the idea. So remember, everything is typically some kind of verb or API call, right? These policies either get attached to users, groups, or roles, and they define what permissions the user, the group, or the role has. Okay. By the way, if someone comes in and says you are denied access to EC2 explicitly, then no amount of allows will ever let you talk to EC2. You have to remove explicit denies to access before an allow will be interpreted. Otherwise, just know that everything is invisibly or implicitly denied. And so if you grant an allow, that is allowed. But if someone says, you know what, Michael Forrester can never touch EC2, we have put a deny on his account, it doesn't matter how many allows an administrator puts on there, I won't be able to touch it. So user credentials and how they work. So I mentioned already about the root email and password, right? Sign in, create an IAM user, put that away. IAM username and passwords are used to log into the console. So if someone says you need a username and password, you assume that they're logging into the console. If they ask for an IAM user access key and an IAM user secret access key, that means they're going to access it on the command line or through the SDK, the software development kits. If they're going to do that, that means they're going to do programmatic non-console work. So just know that you're either going to give users a username and password, or you're going to give them an access key and secret access key, probably both actually. But I do want to mention this. Please do not give users access keys that you're giving them. Give them some way to retrieve it themselves, so that way the chain of custody is broken. The only people who should have that key is the user themselves. No one else should be seeing those keys, right? That way there's some exclusion there and accountability is really strong. So just note that you might give them a username and password to just their ID so they can create their own access key and secret access key. Okay. I don't even know why MFA is listed here, except that it is a credential type that is an enhancement, right, over something that you know, it's something that you have, right? So MFA, multi-factor or two-factor authentication, we're familiar with because we use it all over the place. And it basically either sends a text and gives you some information to your device, or you have to use some kind of, interactive code, right, to get logged in. Most of us use the code. Amazon supports the standard Google authenticators, the Apple authenticators, Microsoft, it'll support all of those. And Amazon has its own authenticator if you want to use that. Here's an example of an access key and a secret access key. Notice that if you're on the command line, you can configure that along with a couple of other things like your region or whatnot. If you're using the SDKs, by the way, it's going to use the credentials that you create in the command line, or you can hard code the credentials in a config file. Let me tell you right now, please do not stick your credentials inside of any code that you're going to check into a repository. If you even do that, by the way, Amazon will usually know within about 15 minutes. They'll actually lock out your user in your account and then send you an email and say, hey, by the way, someone just posted your keys up on GitHub publicly. And so we just locked down that user so that user can't do anything because everybody can see that. So just know that Amazon is proactively scanning all of the public sites, including Gists, GitHub, GitLab. If it sees you post something publicly, they will automatically lock you out of the user from doing anything programmatically. You can still log into the console. Okay. Notice the access key and the secret access key are these big, long alphanumerics, right? Now, contrast this to users. Groups don't really have any authentication information assigned to them. They definitely have authorization information granted to them, right? So, for example, if Richard, Anna, and Shirley are part of the analyst group, they get a different set of permissions than if they're part of the admin groups. Just a kind of a general best practice. Don't attach policies to users, attach them to groups, and name your groups intuitively. If it says S3 read-only access for Project A buckets, guess what that grants? Read-only access for Project A's buckets, right? If it says S3 full access to Project A's buckets, guess what? So my point being is that when you do group names, try to do them intuitively. Not everybody does that. It really kind of blows my mind a little bit because it makes it really hard to figure out what policies you're granting unless you actually go through and do a full analysis of someone's policies. They do have an IAM access analyzer that will tell you whether you have access to a specific resource, but man, that still gets problematic, right? So just something to be mindful of. Okay, roles. Users and groups make total sense to us, right? We've been dealing with users and groups for since we've been born, right? We understand this. Roles are a little funky because unless you're a Linux admin or a Windows administrator, you're kind of like, well, what is a role exactly, Forrester? I always like to tell this little story. So think of it like roles socially. I'm Michael Forrester. That's not going to change. That's my identity. But I have different permissions with my mom versus different permissions with my son. Like if I walk up to my mom and I'm like, hey, mom, hey, we got guests coming over tonight. Your room's really not up to standards. Smells a little iffy. Would you mind cleaning up the room, making it smell a little less, maybe put your dishes away, right? You can imagine how that would go if you said that to your mother. Hopefully she's nice about it. My mom would be more likely to shoot me in the pinky toe because that's just the way she rolls. So if I talk to her like that, she would look at me like I'm crazy, and there might even be some act of violence committed upon me because those are son permissions, like those are father permissions, right? Those aren't son permissions. If I go to my son though, and I'm like, hey man, your room's kind of iffy, it smells kind of funky, we got people coming over, don't really meet standards, can we make sure this is cleaned up in the next 90 minutes? He might give me some sass, but at 14 years old, but he's going to be like, hey, yeah, okay, no problem. Or he might even barter, right? So because I have different permissions with my son than I do with my mom. Now those are societal roles, and we don't really those are kind of inherited. We don't really negotiate those all the time. Here you actually get to declare your roles. Now most of the time you should be operating as an unprivileged user. You're in there read only, messing around with stuff, and if all of a sudden you need to go in and start up a DynamoDB database, you would then switch to a role that would grant you the permissions that you're looking for. So just be aware that role switching, which by the way, you can only have one role at a time, but you could switch to different roles for different purposes. This will give you a different set of permissions. Doesn't change that you're still your user, but this is particularly poignant if you have to be the security auditor for 50 accounts. Instead of getting 50 different username and passwords, you could have one username and password, but you could assume a role in each of those other 49 accounts. Maybe that's a read-only role. They would have to create the role in their account, and then they would have to trust your user ID, particularly your Amazon resource name. It's called an ARN. They'd have to trust your ARN to assume the role. So to be clear, roles are not just wide open for anybody to assume. You have to say in the account that's going to be targeted, you have to say who can assume the role. So they're not unrestricted, they are restricted. So not anybody, for example, could just walk up to my mom and be their son. It has to be somebody who's been approved for that, which I don't know how I got that, maybe just because I was birthed, right? Same thing, right? You've got to grant a trust relationship between the role and the people who can assume the role. This, according to Amazon, is used only for temporary access. I'm just telling you their perspective on it. I have a lot of permanent services that have roles attached to them. So, any questions about users, groups, or roles before we go forward? Okay. Wow. That doesn't really bode well, right? When I laugh evilly, maniacally. Okay. Now, how do you assume a role? Well, actually, you know what? Let me show you. Actually, let's diverge for just a second. All right. Let's say I'm here and I'm like, Michael Forrester needs to log in to his demo account. So we're going to go to the management console. We're going to log back in. Apparently, we're not just going to log in. And immediately, by the way, it's going to show some kind of old thing. And you know what? I'm like, you know what? Let me sign in as an IAM user, right? So I sign in. My son calls me Spartan Sage, by the way, which is why I use that. name. Let's see here. MFA for the win, even though it slows the demos down. All right. So now I'm logged in. I want you to notice on the upper right-hand side, it says Spartan Sage at the account M Forrester. How do we know that? Let's go take a look at IAM for a second. So notice over here, it says that I have an account alias called M Forrester. But my actual account ID is 0676 blah, 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 right? The reason this should be significant to you is that that account has an alias. So it says Spartan Sage and M Forrester, but that account ID is what you need in order to switch roles. So if I was going to switch to a different account, I'd actually copy this account ID, right? But I'm actually going to stay in the same account because I don't want to mess with organizations and all that, because I actually had an issue earlier today and I don't want to deal with that again. But let's say I'm here and I've got read-only access in this account. That's it. What would happen is I would come up here and I would click on switch role because I need to like create an EC2 instance. So I click on switch role. First thing it's going to do is going to give me a little tutorial. No matter how many times I've done this, it gives me a tutorial on how to do this every time. I'm going to click on switch role. I'm going to paste in my account number and I'm going to type in the role. Now the role just happens to be M Forrester admin. How do I know that? Right? Well, because I created it. Okay. What's it say in the upper right-hand side now? It says I'm now an admin at my existing account. I just typed that in. You know what it would have said? It would have said M Forrester admin at account number if I hadn't typed that in there, right? But basically now it says I'm an admin, right, inside my account. If I go in here, by the way, and look at the roles, and I go to M Forrester admin, assuming I can type it correctly, notice that there's a section here that not only grants my policies, which, by the way, this is an administrator access role, but now I've got a trust relationship. And basically this trust relationship says any user who's in this account can assume this role. Now, obviously, that's not how you're going to do it in an enterprise, right? But I'm the only person in this account, so, you know, I'm going to set it just for me. Okay? So this is where you go in and say things like, oh, you know what? The only person who can assume this actually is Spartan Sage, right? Oh, actually, wait. Oh, no, I'd have to do something a little bit more complex. We're actually going to leave that as root. My point being is that, sans my inability to actually type out policy conditions right now, is that you could actually put in here and say, look, the user has to come from your home IP address. The user has to be Spartan Sage. The user has to be part of this group. You can set conditions here that basically say, hey, this user can only be pulled actually if these following conditions are met. I know why it's doing that, by the way. It's because I actually set up a SCP rule. Remember my whole issue around logging in earlier? I actually shot myself in the foot by messing with organizations too much. And now my demo account's in a weird place. So just note that you can actually set conditions in here as you see fit. All right, so then once I'm done using my role, I can just like switch role, right? Switch back to where I was. And notice I'm back to my base user, right? So that's how a role works. You have an identity and you switch to the role. You can do this on the command line as well, okay? You can assume a role. It's going to return some temporary credentials, and you are now operating as that elevated set of security credentials. That's what changed. One thing that's worth mentioning is that there's a service at play here called the secure token service. The secure token service is the one that passes out the security tokens based on permissions to do so. Okay, not just for anybody. It's for people who have the right authentication and authorization. Well, really the right authorization, right? Policies can be assigned to users, groups, or roles. They can also be assigned via roles to services, also known as resources, okay? So there's a lot of use for roles. You can actually also create what's called service roles to do like create permissions for entities that aren't necessarily AWS resources. That's actually super cool. Think of roles as limited sudo access, right? So let me ask you this: if AWS comes to you on the exam and says we want to grant you temporary access credentials, which of the three entities are you going to say? So you're going to say roles, actually, right? That's how you're going to pass. Just use an AWS role. Okay. All right, let's talk about security policies. So, how do we restrict permissions in AWS? So we talked about the principal entities, users, groups, and roles, including assigning roles to services and whatnot. What about the policies themselves? There's about 4 different ways. All right, there's like 4 different ways to restrict inside of AWS. 1, there are identity-based policies which are attached to users or groups or roles. Then there's resource-based policies which are attached to services. Resource-based policies only exist because there was a time when IAM wasn't around. I think it came out until 2011. So there are some services that were created before 2011 that allowed you to assign policies to them, and they dictated who and what things could be done to the service. Now, this is how you grant permissions, okay? So when we're talking about using identity-based policies and resource-based policies, we're talking about definitions that say what someone is allowed or denied from doing. But mainly it's used to grant permissions, not deny permissions. Mainly. It can be used to deny permissions, but mainly it's used to allow permissions. Just know that policies come in 2 flavors. AWS generated and managed that you can use, or your own custom policies that you can create. So just know Amazon does maintain like read-only policies and full access policies. Most enterprises don't use them. They generate their own policies. Now, you can actually make it so that a role has access to resources, and those resources have their own policies attached to them. I just want to mention this is that this is defense in depth. It is nice. It can also very much hurt you when you try to make a change around security policies. So, think about the outcome you're trying to achieve and what your security compliances and requirements are, because you can very much lock down something and defend it, but you add 4 layers of security, that's also going to add some complexity. So make sure you've got some level of automation if you're going to do this level of sophistication on your defense in depth, okay? Now, there's a couple of types, as I mentioned, of identity-based policies. There's AWS managed, which means they're generated, and can be used to grant both users and services access. Or there's custom policies, and those are ones that you've just generated. No big deal there. Now, the elements of a policy. The elements are, first of all, are you denying or allowing someone to do something? Those are the 2 states. You're either saying yes or you're saying no. That's the only options you have. You're either saying, yep, this person can do this, 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 and this, or you're saying this person cannot do this, this, and this. That's it. First thing is effect. We're going to ignore principle for a second because those are resource-based policies. We're going to skip those for a second. The second is the action. can they do anything they want with EC2, or can they only describe stuff in EC2? Can they list everything with S3, or can they only describe, can they delete stuff with S3? And then are there specific S3 buckets or specific EC2 instances? Are there specific resources they're granted access to, or are they granted access to any S3 bucket, any EC2 resource? And last but not least is conditionals, which are not required, which basically says, are they only allowed to access it through this time? Do they have to come from this IP address? Do they have to use SSL? Right? Like TLS, TLS, right? Not SSL. Like, do they have to use encryption? Right? And then just to say this, principals are actually only used with resource-based policies. Principals say this user can actually talk to me. So remember, identity-based policies are attached to a user. Resource-based policies are attached to a service. Principals exist on services because you have to, if you attach a policy to S3, you say, hey, S3, M Forrester, Spartan Sage, and L Forrester, they can all read you. So remember, when you attach a resource-based policy, you also have to say what users can do what, right? So if it's identity-based policy, you don't have to define the identity. You know why? Because it's already attached to an identity. With a resource-based policy, it's not attached to an identity. So you have to say who the principal is. Is it a user, a group, or a role that can talk to me because I'm the resource or service, right? Now the policies look like this. So here's a few questions for you. Once you look at that in green, I know you may have never seen IAM policy before. First of all, does this deny or allow somebody access to something? Good, definitely allows. Okay, what two services are we allowing access to? Good. And by the way, what specific things can we do with DynamoDB and S3? What are we allowed to do to those two services? Give me one word. Yeah, everything. I can do anything I want, right? Anything. And then as Kyle stated, there is literally one bucket and the contents of that bucket that I can talk to, and there's a specific DynamoDB table, right? So Kyle just called it out. He said, look, resource-wise, we defined the specific service resources that I can talk to. Note, by the way, man, I don't know why this is. I think it's because S3 predated IAM. When you grant access to an S3 bucket, you have to grant access to the bucket itself and the contents inside the bucket, which is what that / is. That / means everything inside the bucket. I don't know why that is. I'm sure it's actually in the doc somewhere, but I can't find it. This, by the way, this policy is an explicit allow. If that said deny, by the way, and that was attached to a user group or role, that user group or role would not be allowed to touch that bucket no matter what. You have to remove the deny, the explicit deny, before explicit allows are allowed to work, okay? So even though you've never seen an IAM policy before, you can read that. You might not be able, not know like every single asterisk and what that means, but if you see an asterisk, by the way, it basically means anything. Good. Here, by the way, they flipped it and they did a deny. Everything got blocked, right? Now, the only thing that's missing that's optional, by the way, is what if we added a conditional? What if we said that this allows a user to stop and start any instance where they're the owner, right? You can say, oh my God, IAM as far as conditions goes can get so crazy. You can set all kinds of conditions, date and time, IP information. You can set conditions on tags, on resources. Do they own it? Do they not own it? You can set negative conditions like, you can have access to everything except for this, right? So conditions are complicated and fun. Now, this, by the way, shows a quick summation of like, are they explicitly denied? Then they'll never get access, right? Denied. Are they explicitly allowed? No? Well, then they're implicitly denied. They're invisibly denied. But if they're allowed access and there's no explicit deny that says they can't do the thing, they can do the thing. They can do it, right? So just remember, implicitly, invisibly, by default, you are denied access. You then can be granted access if you are denied access explicitly in a file, in a policy. You cannot get access to the thing. Now, those were all identity-based policies. So do me a favor. I want you to list the 3 types of principles or like that can have identity-based policies attached to them. What are the 3 IAM principles that can have policies attached to them? George, that's really good. You got really close. You were almost perfect. Roles and users, definitely, but there's one missing there. Because you can definitely attach roles to services, but policies can only be attached to roles, users, and groups, which is what Ryan put in there, right? So roles, users, and groups. So close, right there, right? Users, groups, and roles are the 3 principles that you can attach policies to. Anything else is going to use roles. Let me clarify that. Policies can only be attached to those 3 IAM entities, but if you want a service to have permissions, you're going to attach a role to the service. If you want Active Directory to have permissions, you're going to attach a role to Active Directory. If you want Ping Federated to have permissions, you're going to attach a role to Ping Federated, right? So just remember, you have to attach a role to whatever federated identity you have, and that includes AWS services. Cool. All right. Now we're switching to resource-based policies. Notice the difference here. The only difference between this and the other thing that we saw was that they have added a principle. First of all, the effect is there. What's the effect? Allow. What's the action? Well, it's very specific this time. It's S3, and it's the put object API call, right? And then notice here, the resource is the my bucket folder 123 star. So they called out a specific bucket with a specific folder prefix, and you can put anything into that folder underneath that bucket that you want to, as long as you are account 11111222233, right? So remember, this resource-based policy would be attached to the my bucket. This would be attached to my bucket, like the bucket named my bucket. If you want to review permissions, by the way, there's a service called Access Advisor. Just know that it's there. It's very useful. It will show you, by the way, what people have been doing inside their account, right? Do I even know? Let's go take a look at this. I'm not in the console very often. Let's see. I think if I look up Spartan Sage, and there's the Access Advisor, it should show you everything I've been doing, which hasn't been a whole lot, actually. This account. Oh, yeah, I was messing with Control Tower. See, this is where I shot myself in the foot. I was messing with Control Tower. And then organizations, yeah. I did things that I might regret. I actually do regret. I'll have to fix them at some point in time. So just know this is actually going to show you where everything was accessed. You can obviously go back. Work docs, connect wisdom, funny. Anyway, this will show you everything that you've been doing in the account. This is called Access Advisor, just one of the tabs inside of your entities. Now, this is the Access Advisor, right? The Access Analyzer is a little different. So the access analyzer, by the way, is accessed over here under access analyzer rules. And if you look at this, if you have any active kind of like analyzer rules like set up, for example, it's showing that I had a Datadog integration against the account. I had, I was basically modified it so I could allow anybody to access this bucket, right? You boost people are like, what? Why does he have a BAH admins? It was for a boost thing, right? So just know the access analyzer, you do have to set up, analysis like findings, but it will look at your account and let you know if you have something exposed in your account. Okay, so if you shared an S3 bucket or a role with something outside of your account, or another service, like in this case, you see Cognito listed there, it'll basically say, hey, by the way, you shared this with a service. This is just a reminder of like, hey, is that what you wanted? So it's a great way to audit. Now, we've been talking about granting permissions. What if you need to deny permissions? So just know that at an account layer, you could grant somebody administrative access and then create exceptions, right? You could say, look, this person can't do anything, right? So permission boundaries are a way at the account level, not the organization level, at the account level to limit someone's permissions. So you could grant them permissions and then say, but they can do anything they want in the administrator thing, but they can't change the organization or they can't mess with administrative users. So this is mainly used if you want to create sub-administrators, right? So you want to give somebody a bunch of permissions, but you want to exclude them. I got to tell you personally, I don't use boundaries. I just define the permissions for those people the way I want them to be. But there are use cases where you might want to create exceptions. I don't do that, but you can. So people do need this. So permission boundaries act as a filter. If you have not granted the person access to do the thing they're asking for, and they've been given access on an identity-based policy, the permission boundary always wins. So the permission boundary will scope their permissions down to whatever the permission boundary is set to. This sets their maximum permissions. Just to be clear, permission boundaries do not grant permissions, they simply block permissions. So someone has to be granted permissions inside of an IAM policy, and the permission boundary will like restrict it, right? Sorry, just closing my door really quick. It's actually cold outside. So policies can be used in conjunction with permission boundaries and identity-based policies can be used to scope access. One thing where I kind of just jump ahead a little bit for is that when you're managing an entire set of accounts, you can use these things called SCPs or service control policies. They will also allow you at the organization's level to block a bunch of service availability inside of an account. So we're going to talk about organizations at the end, but just know you can also use that to block access to services. Remember, identity-based policies and resource-based policies are the only ones that can grant permissions. They can also deny permissions. Permission boundaries and SCPs can only deny permissions. So even if you say someone can't use the quantum computing service, someone at the account level still has to go in and say, like, that you can use other services, right? So just know, at the account level is where permissions are granted. At the SCP level, which is an organizational level, means that you're managing a bunch of accounts, that can only deny, okay? We're going to talk about that as we get to the end about what an organization is and what SCPs are, but just know that like they can only deny permissions right now. Okay. Any questions about how policies function? You know, how this kind of thing works and the difference between resource-based and identity-based policies? Yes, Kyle. Identity-based policies are attached to either users, groups, or roles. Resource-based policies are attached to services. So I'll give you an example. Let's go take a look at S3, for example, just to make sure this is super clear. S3, by the way, will let you use identity-based policies, and it will let you resource-based policies. It'll do both, right? So for example, in order for me to make BAH admins public, what I actually had to do is I had to go into permissions for the bucket. So notice I'm in the BAH admins bucket, and I had to actually set a bucket policy. Now look at this. This bucket policy says that basically anybody in the world, because I didn't specify an account number, so now I'm like outside of authentication for IAM. I said that anybody in the world can basically get to this bucket as long as they're hitting 2919 prefix. This is the big difference between an identity-based policy and a resource-based policy. And this policy is attached to this bucket because that bucket is an S3 resource. If this was an identity-based policy, there would be no principal, and it would be attached to a user, not to an S3 bucket. So this is the difference between resource-based policies, which are attached to services, and identity-based policies, which are attached to users, groups, or roles. Now, the thing that gets really weird is you're like, but Michael, earlier you told us that roles, which are part of identity-based policies, roles can be attached to services. Yes, I did. So there's two ways to solve this problem, right? You can attach something to an S3 bucket, or you can take a role and attach it to an S3 bucket. But just to say this, there are some things, because some of the services are so old and they have like a peculiar kind of history, you actually have to use a resource-based policy to get things done. Like you can't actually use a role to make it happen. Amazon is slowly phasing that out, but there's only 5 services that still accept resource-based policies. It's like S3, SNS, SQS, OpsWorks, and something else. I can't remember. So S3 requires this in order to make it public to the entire world. But resource-based policies go to services, identity-based policies go to users, groups, and roles. Is that helpful? That's exactly right, Kyle. You got it dead on. I could not have said that better. Yeah, you got it. Trying to think of another one that has policies attached to it. Let's go take a look at SNS. Oh, actually, let's go look at topics. Wait, I don't have any topics? How did I end up with a subscription? Oh, interesting. Anyway, if I go out here and create a topic, let's say it's just a standard queue, right? Test, no encryption. Oh, access policy. So here, by the way, this access policy, notice it has a principal listed into it. See that principal? That's a resource-based policy. If it has a principal in it, it's a resource-based policy, especially if it's attached to a service. In this case, this is SNS, right? SNS is a notification service. So notice that once again, there's a policy here that's not attached to a user, a group, or a role. It's attached to a service, and it has a principal in it. This is a resource-based policy. SNS, by the way, like SQS and S3, is one of the oldest services. Iterated a lot, so don't let me make it say like it's abandoned, because it's certainly not. But these services predated IAM, and so they have resource-based policies. There are some things that you can only do with resource-based policies, but that's changing. Okay. Any other questions? I love how when I scroll through, it just like shows it like one at a time. It's funny. Okay, so let's talk about federation. I mentioned this before, but if you want to hook IAM up to a federated user database like Active Directory or Ping Federated or Okta, those are third parties, by the way. Those are third-party pieces of software you can pay for that will host users and groups, right, for you. What happens is that AWS can federate with any identity provider And any identity store that supports that SAML 2.0 or OpenID Connect standard. These are standards, right, for passing security information around. You have to require metadata certificates in some cases, right? And so goal number one is that without single sign-on, which by the way is a service inside of AWS, without single sign-on, you're going to have to log into all of these services separately, separate from AWS, right? And so users are going to be forced to authenticate several times. What you can do is you can actually turn on single sign-on, federate with Active Directory, and if Active Directory is hooked into IAM, specifically the single sign-on service, then you can get access to AWS accounts, and you could get access to external services, okay? So just know that Amazon, as part of federating with IAM, with the actual Identity Access Management Service, they have a single sign-on offering. How sophisticated is it compared to other services? It's about 80% there, but it is also free and it's integrated in with AWS. So depends on what your use case is. If you're a brand new company, this is probably very appealing. If you're an established company, you probably don't need this because you've already figured out how to solve this problem. If you haven't, then maybe you would look at this actually. But this is single sign-on. Basically allows you to hook in all of your identity providers into one place with Amazon. Notice it supports Salesforce, Box, Dropbox, Office 365, Google. It supports a lot of web identities. Okay, the only thing you need to know is that single sign-on exists and it can federate with Active Directory and a bunch of other services. So if that felt like a marketing skim, it kind of was actually. All right. All right, last but not least, let's talk about organizations and Control Tower, which I just referred to as kind of shooting myself in the foot with earlier, which that's an interesting phrase. I kind of wrecked myself earlier with Control Tower. Here's the reason why we care about organizations and subsequently Control Tower. If you do not scope and control, and I use that word really loosely because I'm not a fan of overtly controlling stuff and kind of like stifling innovation, but I'm not a fan of just people going wild, wild west because the next thing you know, you've got no security, no oversight, no auditing, no defense, no preventative measures. You know, it's this kind of balance, right? If there weren't hackers in the world, then we could leave all our front doors open. But there are, so we have to deal with that reality, right? Organizations allows you to take, hundreds, if not thousands of accounts and create a policy that you can apply to all of them to make sure that none of them are doing weird things like opening up their web servers up to the world without some kind of web firewall in front of it, right? Making S3 buckets with security information available to the entire world. Using quantum computing when you're not in the business of quantum computing. Using the virtual reality service when you're not in the business of doing virtual reality, right? Which maybe we all should be, but that's another discussion. So without organizations, you have to do all this manually. With organizations, just like in Active Directory, you can actually create what's called organizational units and apply policies to these organizational units, and they trickle down to all of the accounts that are part of it. You can control the trickle down, by the way. You can apply it at the root user and have it trickle to everybody in the account. You could make a production OU versus a non-production OU. And then you apply what's called service control policies, and they literally stop someone from running quantum computing or running virtual reality without talking to somebody in the enterprise. Just stops them. Now, having been the subject of this, I know it's frustrating. But when you're running a large organization, bureaucracy is part of the equation. And that includes these kind of controls because when you're a $50 billion company, people are looking to get to your information. And quite frankly, in our litigious environment, they're looking to sue you in a lot of cases. So you got to have these kind of security measures in place because people are either looking to steal or find vulnerabilities. It's really about reducing risk. I've never been a security person, but I respect what security tries to accomplish. and the job is practically impossible in today's age. So, this is one of those things that kind of helps them kind of scope and protect an organization, right? So the other thing that's cool about organizations is not just the protective measures, there's also detective measures, which means you can actually set up detections for when things happen so you can get notified if someone punches a hole in a firewall or if all of a sudden someone starts doing recon against your network. You can set up what's called detective measures as well. The other cool thing is that you can set up consolidated billing. So with an organization, you can get Amazon to bill all of your accounts to one account, and then you get volume discounts. Now, I'm not a fan of pay more money to save more money, but when you're an enterprise, like the other day, let make it sound like it was yesterday. This was years ago. We turned on consolidated billing for a series of accounts. Instantly, just because we started aggregating all of our S3 usage into one bucket instead of there being 50 buckets, they billed us for all of our storage. We saved $7 million a year just by turning it on. Now, that is an unusual example. I've been in the industry for 25 years and haven't had that happen before, but it did happen. And so just know that when you put something into an organization, it's not just a security enhancement, it's also a billing enhancement. And remember, those are the two things I said were harder in cloud, is security and billing, right? By the way, you can disable consolidated billing and you can disable the SCP trickle down if you want to in organizations. You might have accounts that you don't want to consolidate with and you don't want to be part of your security policies. Good luck with that. Other things to know. Remember this slide? Hold on, we're going all the way back. Remember this slide back here? Way back here. Where we're talking about identity-based policies, and then we're talking about permission boundaries, and then someone snuck in SCPs in here before we had even talked about SCPs, right? SCPs are those service control policies that I was talking about before at an organizational level that can prevent a user from starting a service. So if we go back to this is where identity-based permissions and organizational-based permissions, this is where they overlap. If an organization SCP says you can't do something, then no amount of grants inside the account are going to allow that to happen. But remember, SCPs do not grant permissions, they allow permissions to happen, right? So notice it says allowed at the top. It doesn't say granted. If you want to grant permissions, that still has to happen at the account level. If you want to allow permissions, that can happen at the organizational level. So these act as a filter, not a grant. Okay? Here's an SCP example where basically we're going to allow people full access to EC2, but we're going to restrict it to a specific region. That's smart, by the way. You know how hard it is to find resources that have been stuck in like fringe regions? Don't worry, it shows up on the bill, but you still have to go looking for it. Now, there is an enhancement to organizations called Control Tower. Control Tower is, think of this as a vending machine of best practices for your account. If you're starting out brand new, by the way, with a company, or even just starting a new like business unit, setting up Control Tower is actually pretty cool because it automatically sets up a security account, an auditing account, and it sets up a vending machine so you can just create accounts, and the accounts are automatically compliant with your service policies. So it's a great setup. So it allows you, by the way, to enforce governance, get continuous visibility into what's going on into your account, and it basically allows you to like set up hundreds of accounts that are all under that same umbrella of enforcement and oversight. So it's actually really cool. So just know you could get a best practice template for all of your accounts if you wanted to. All right, questions about organizations. What it does, what its purpose is. Who dominates between SCPs and identity-based policies? All right, here's a little knowledge check. 1, which of the following can be attached to a user group or a role? Which of these can be attached to a user, a group, or a role? Good. Identity-based policies, right? Remember, those policies are attached to roles. Resource-based policies are attached to services. Okay. Which policy type is not assigned to a security principal and can grant permissions to a specific resource? The answer is in the question. Good. Yeah, resource-based policies. Excellent. Which of the following are benefits to using roles? 2 answers here. And remember, you have to think about how Amazon talks about these things, about roles. Because C and D are opposite answers, right? Okay. So, roles are excellent if you have to manage multiple accounts. So definitely B, because they're used for cross-account access all the time. That way you don't have to create a user in all the accounts. You just have roles in those accounts and user somewhere else. And then remember, burn this into your brains. If you hear the word role, Amazon wants you to think about that as a temporary grant for permissions. Temporary, 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 temporary. Like Steve Ballmer. Developers. Temporary, right? If you hear the word role, they're saying temporary, right? So increase security by giving temporary permissions. Now, in practicality, is that temporary? Arguable, but that's the way Amazon thinks about it. They want you to think about it as temporary access. Okay? Good. Okay. The root user should not be used for daily administration of your AWS account. Is that true or false? Very true. That is true. Should not be used, right? Put that thing into an emergency case. Do not break in case there's an emergency. Let that thing go, right? Don't use it. All right. Okay. Remember, you want to use an IAM user. Okay. What can simplify logins for customers using Active Directory, AWS accounts, and other third-party services? How can we simplify logins for customers? What is the service? Yes, good. B, seen it. Perfect. Single sign-on. Which of the remaining services is actually used for multi-account management? Out of these listed here, which of these is used for multi-account management? Good. Good. Out of the 2 remaining, which of these is used to grant the token that provides temporary access? Well, Ryan just threw it out there, right? He says, I forgot what STS is. Ryan, that's what it does. The secure token service is used to give the temporary tokens, like the temporary permissions, that things like roles use, right? So anybody who wants a temporary access, whether it's a pre-signed URL or a role, they're going to use the secure token service. Man, people do not talk about the secure token service, and that's weird because that thing has been there for a while. So By the way, if you were in the developer track, you would learn more about the secure token service. It's mainly used by developers, but we use it all the time underneath the covers with roles. Okay. That took exactly as long as it was supposed to take. Who's up for a 10-minute break? Maybe a little 10-minute break. We've been talking at you for a minute, right? Okay, I saw it. Good. All right. So currently it is, let's say it's 2:45. So I want you to come back at 2:55. So that's literally 12 minutes from now, right? Come back in 12 minutes, okay? We'll see you in a bit. Probably would help if you could hear me. Any questions about anything we talked about in the prior section? Okay. Okay. Are you ready to get re-engaged around networking and all the stuff that you probably knew if you're not a network engineer, but totally forgot? No? I'm just kidding. It's not going to be that horrible. But it is kind of fun, actually. And it is used everywhere. So still incredibly relevant today, actually. It's how the world runs underneath the covers. Okay, so let's talk about networking. First, this is an interesting question. What percentage of your workloads are publicly accessible? I don't know who they think takes these classes. I don't know that any of us really know, like an entire company, but like, let's answer for your own personal workloads. Do you know how many of your own personal workloads are publicly accessible? Me neither, actually. They really ought to have a not sure button here. I think mine is like 10% or less because like I think I have the bucket and that's it. Usually I don't run public workloads. Now, as far as customers go, that varies widely. Okay. Questions are weird. All right, everything in network engineering starts with security. Cool. So should everything, actually. How do we isolate? How do we route? How do we build highly available networks? Sounds good thus far. What about IPv6? How can we filter access? How do we secure our networks? That's a good question, actually. So how do we build dynamic and secure infrastructure in our AWS accounts? How can I divide my networking into public and private clouds? How can I direct and filter traffic that are going in and out of network? Those are great questions, actually. I mean, when would you run a network and not have some kind of firewall on it, especially in this crazy world? Okay, let's take a look at this. All right, so now we're starting to move into our diagram a little bit. So we've gotten past account access, and now what we're talking about is things like internet gateway, NAT gateways, and these public subnets. We'll probably talk about private subnets as well. So it's a good thing to get into. So first, let's talk about IP addressing because, yeah, if you're going to run an operating system with a network card, it's going to have an IP address. How do you make it so those IP addresses work, and how do you deal with overlap between your corporate IP addresses and Amazon? Like, how can you choose ranges that don't have overlap? Makes things a lot easier, right? So, okay. So IPv4 was developed in the 80s and uses 32 bits divided into like 8 groupings of 4. So that number, dot number, dot number, dot number, that's 4 sets of 8 bits. I'm not even going to talk about binary here for a second, but that, because there's 8 bits, so if you take 2 to the 8th power, is that right? 2 to the 8th power, 4, 16. Yeah, I think that's right. I could be getting that wrong. I think it's 2 to the 8th power. Then the maximum you could get, so for example, 2 times 2 is 4, 4 times 2 is 8, 16, 32, 64, 128, 256, right? So 0 to 255, because 0 is always 1 with computing, 0 to 255 represents the maximum number range that you could get in between any of those periods. Now, some of you are like, Michael, oh my God, really? Is this what we're talking about? Yes, it is, right? This is what makes up an IP address. After the slash, that tells you how many bits you're going to use for defining a network versus the number of hosts that are on that network, right? Now, a /16 means you're going to take the first set of 8 and the second set of 8 and the last 2 sets of 8, which is really the last 2 numbers between the last 2 dots. That's going to give you 65,536 possible addresses you could use. I know. You're like, really? Yeah. And don't worry, there are calculators out there that you can use for doing what they call CIDR or subnet ranges, and that will allow you to figure this whole thing out. Just know that most network engineers and sysadmins will just do this in their heads, right? Because that's what they have to deal with all the time. IPv4, by the way, the one from the 80s, has 4.3 billion allowable possible addresses where 0 to 255 could fill any of those numbers, right? Now, as you can imagine, there are trillions of devices that are indirectly connected to the internet. Trillions. Probably more than that, right? So just know that 4.3 billion addresses isn't going to cut it, right? So how did they get around this? They actually took a slice of these ranges and said some of these are going to be used for private networks and cannot be connected to the internet. 10.0.0.0, that whole range, anything that starts with a 10 is a private address and should not be published on the internet. If it is, it's going to be ignored, or you're going to have routing problems. 192.168, which is what most of our private home networks run, that's a private address as well. And then 172.16 and all the way up to 1.72.31, if I remember correctly, those are all private ranges as well. So when you create a network, a VPC inside of Amazon, it has to either start with a 10, start with a 172.16 to a 172.31, or it has to start with 192.168. That's all part of RFC 1918, which they list there on the left-hand side. That's a document, a request for comments document that lists that these are the IP addresses that are used for private ranges, okay? You can look this up, by the way, and Amazon's not going to let you use any IP addresses other than the ones that are in that RFC. So just know that even if you don't remember half of what I just said, Amazon's going to scope you down to the right ranges anyway, okay? As a general rule of thumb, you should be using a 10 address because you probably want the most addresses possible. So you never know because people run out of addresses. So you probably just want to use a 10 address when possible, okay? You can use a 172, you can use a 192.168. Doesn't matter. It depends on what your policies are. Now, IPv4 on the left was developed in the 80s. So let's see, IPv6 I want to say was developed in the late 90s, if I remember correctly. So 1998, if my memory serves correctly. This one, by the way, has a mask of /56. There are 340 trillion addresses. Did that sound like a lot, by the way? 340 trillion IP addresses available in IPv6. And we're probably still going to run out in about 100 years. Assuming that we're even still doing things the same. But whatever. Numbers are grouped into 4. So there's 4 digits in between each of the semicolons. And as you can see, there's 1, 2, 3, 4, 5, 6 blocks, right? So the groups are written with a colon as a separator, right? And this is considered a 128-bit address. So IPv6, unlike IPv4, which only uses numbers, IPv6 uses alphanumeric hexadecimal notation. So just one thing that worth saying is that you cannot disable IPv4 inside of your VPC, but you can add support for IPv6. So just so you know, there are no private IP addresses, to my understanding, in the IPv6 range. Basically, every address could be internet routable if the internet is connected to it. So IPv6 is not commonly known, nor is it not commonly understood, but some people need it, and if you're looking to expand into new IP spaces, you have to use it. Okay? Because we're out of IPv4 addresses. We're done. You can't buy. If you don't own any IPv4 blocks, I don't think you can buy anymore unless it's from an auction. Now, CIDR, which is basically a way of subdividing or subnetting, right, a particular block of IP addresses, you can basically assign a size that is as large as a /16, which means you can get 65,000 addresses. You can see that on the right-hand side. Or you can do as small as a /28, which will get you 16 usable IP addresses. This is 100% on the exam. The smallest range you can use is a /28. The largest you can use is a /16. Memorize it. Don't forget it, because it's going to show up. They're going to test you somehow. It's going to be either in the answers or there's going to be a specific question about it. They're going to say, hey, someone's trying to use the /29 but keeps running into errors. And the answer is going to be, well, you can't use the /29 because /28 is the largest, the smallest network you can create. Okay? So just remember that. Interesting. So you can actually create 5 different IP ranges attached to a VPC now. It used to that you only had one, and now you can actually attach what they call secondary ranges. So a VPC can actually be made of all kinds of blocks of IP addresses, where it used to just have to be one before. But you can have a 10.1, you can have a 10.2, a 10.3, and a 10.4, 10.5. So like it says, up to 5 blocks, right? All attached to a single VPC. And the networks inside of that VPC could all be part of the 10.1, 10.2, 10. Whatever, right? So it's really hard to run out of IP addresses now, even with IPv4 on Amazon, because you can create these networks that are actually supersets of IP addresses. By default, all VPCs and all of the subnets that are inside these VPCs must have IPv4 addresses. IPv6 can be added, right? You can associate an IPv6 block with your VPC, but you have to support IPv4 because Amazon's internal network still uses IPv4 and it uses IPv6, okay? Now, once you've decided what kind of network you want, which you probably have a mixed network of IPv4 and IPv6, what needs to happen is that you then need to have public and private like subnets. Think of VPC as a networking pie. If you're using a 10.1 network, your subnets are going to have to start with a 10 and a 1, but that third number could be a 1, 2, 10, 54, 68, 97. As long as it's between 0 and 255, that third number can be whatever you want. Now here, you notice that they have public IP addresses that could potentially be assigned to public subnets, and we have private IP addresses that are assigned to private subnets. But I don't want you to be fooled. Every single device that has a network card, whether it has a public IP or not, always has a private IP address. So they all start out with a private IP address. If you add a public, that becomes a secondary IP. Everything has a private IP address in Amazon. But when you add a public IP, that means it's reachable from the internet, if your firewall allows it. That doesn't happen by default. Okay? By default, when you launch an EC2 instance, nobody has access to it, even if it has a public IP address on it. You have to punch a hole in your firewall to allow somebody to access your instance. But the firewalls are going to stop that from happening. In particular, security groups are the firewalls that stop that. So just remember that when we create a VPC or a virtual private cloud that has networking information associated with it, inside that virtual private cloud, that VPC, we create subnetworks that are a slice of that networking pie. Okay? And some of those subnets are going to be private, some of them are going to be public. Any questions about VPCs, subnetworks inside of VPCs, and whether a subnet is public or private? All right then. Okay. Let's talk about VPC fundamentals then. So, if VPCs are these networking pies that we create, let's say a 10.1 or a 192.168 pie, what we do is that when we create subnets, see, VPCs span an entire region. So they cover multiple availability zones, but when you create subnets, the subnets have to live inside of an availability zone. Why is that? Well, because these are network cards and they're attached, right? And don't worry, Kyle, I saw your question. I'm going to get to it. They are network cards are attached to this, which means they have to live in data centers. They actually have to physically exist. So this has to sit inside of a data center. So when you create subnets, which are slices of a VPC, they have to live inside of a data center and they cannot span data centers. So a subnet is a finite slice of the VPC pie, and it lives in an availability zone because it has to live in a data center. You can create, by the way, hundreds of subnets in a single availability zone, and then hundreds of subnets in the next availability zone, and hundreds of subnets in the next availability zone. And that you don't have to duplicate them evenly. But typically we do duplicate them evenly, at least across two, so that we can have redundancy, high availability, right? The only difference between a public subnet and a private subnet in an availability zone is whether or not it is connected to the internet gateway or it's not connected to the internet gateway. That's it. A public subnet can talk to the internet and the internet can talk to it if the firewall allows that. A private subnet has no direct connection to the internet, nor can the internet talk to a private subnet. Now, as far as questions go, what about the situation where a network is using a 14 for a VPC compared to creating a range? Any idea why that worked? So you can bring your own IP addresses to AWS, Kyle. So for example, if you want to bring your own internet routable range to Amazon and you're registered for it, all you have to do is prove your ownership of the range, and Amazon will let you bring your own IP range to Amazon, and then they'll advertise it for you on your behalf. So you can actually bring your own IP ranges that you own to Amazon, and then you don't have to use RFC addresses. You can use whatever you own. Let's see. I'm guessing the biggest downside was anything in that range that should be public accessible wouldn't be accessible in that VPC. You can actually specify other ranges. Yeah. So the only problem with that is that whoever owns that range is going to be authoritative for it. So if nobody owns the range and somebody just decides to claim it, they could do that, right? But know that if the owner actually decides to assert their ownership of that IP address, like I once worked for a not named company who decided that they were just going to start using someone's unused range, and they just claimed it and used it, and then they advertised for it. But when the company found out, they started advertising for it, and since they were authoritative for the range, they stole it from the company that originally stole it from them, right? So it sounds like that might be the situation, but I'd have to see more of the details to know. Yeah, but a 14 range, unless I'm misreading the RFC, and this says that's reserved for something else, would be publicly routable, right? So, yeah. So I'd have to see the details to know. That's true. You could also set a 14 range and then not do anything externally routable with it. Do note that regardless of what range you set, when you ask for a public IP address, it comes from Amazon's pool, not yours, unless you decide to bring your own. Okay. So let's say that we create a VPC with a /22 as the subnet mask, like the CIDR range, right? And then we decided to divide that up into 4 subnets of 251 addresses apiece. So that's 1,024 total IP addresses for that /22. Please note that in every subnet, right, you're going to lose 5 IP addresses. First one's going to be the network address. Last one's going to be the broadcast address. So in this case, 0 to 255, right? And then the first 3 IP addresses at the beginning of the range are going to be used by VPCs, the router for the VPC, and then 2 is for DNS, and the third is also for DNS, okay? So just know you're going to lose 5 IP addresses. So if you create a /28 subnet with 16 16 IP addresses, you're only going to get 11 usable IP addresses out of that. Okay. So just remember, you're going to lose access. You're going to lose 5. You're going to lose the end of the range and then 3 other usable addresses. Okay. The Internet Gateway, which allows connectivity from the internet, either to or from the internet, right? Internet gateways, by the way, support IPv4 and IPv6. In order for you to get to the internet gateway, you have to have a route table that says, this is where my default traffic goes. No route table entry, it's not going to work. Here's an example. Here's public route table. You got to notice you got a local definition in the upper right hand side. Then for any traffic that is not known to be local, 0.0.0.0/0 in the upper right hand side, that means that traffic is not local, so we're going to send it to the internet gateway just to send the traffic somewhere. So if you don't have an internet gateway associated with the subnet is private, because the internet gateway is a catch-all for any traffic that's not local. If you haven't defined that, then it can't get to then there's nowhere to send traffic. It's just going to drop that traffic on the ground. Notice here the public subnet has the internet gateway defined in its routing table. Think of the routing table as a map. Hey, I'm looking for 54. Blah, 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 blah. Well, it's not a 172 network, so by default, the routing table is going to tell you to go to the internet gateway. How do we know that? Because right here, it's showing that by default, these zeros basically mean any number that doesn't match this. I want you to go here, and I want you to talk to this guy. Who is this guy? Well, that's this guy right here. I want you to go talk to the internet gateway. Otherwise, if it's anything else, like if it's local traffic, like a 172.31, then it's somewhere in here, or possibly in here, right? So it's local traffic. Just find it. Notice that if you were down here at the private subnet, this does not have access to the internet gateway. So it can't talk to the internet. Not directly. Are there ways around that? Of course there are. There's always ways around that. Notice here the private route table doesn't have an entry for the internet gateway, so it cannot get to the internet gateway. Right? Now, by default, Amazon creates what's called default VPCs. In every single region in the entire world, there is typically a default VPC just waiting for you to notice it. Each account comes with these default VPCs. They're always a /16. They're always a 172.31, right? And generally, you don't use them. Why? I mean, you can use them for messing around in proof of concepts, but in general, you don't use them for production traffic because they're a little too wide open. And I'm not saying they're security holes, but typically people want something a little stiffer for security, okay? So not this. Now, most people will create multiple VPCs in their account in order to control access. So they'll have a prod VPC and a non-production like development VPCs and a QA VPC, and then they'll create multiple accounts for each of their products or teams. This all depends on how you want your business to run. This is completely arbitrary. There are pros and cons for doing one over the other, but just know whatever works for you is going to work for you. That's what matters, right? Notice here that they got multi-account on the bottom and they've got multi VPC at the top. Some people will go one account, one VPC. The main reason people do that is because it's really easy to track costs that way. everything in the account is either related to prod for this project or it's related to dev for this project. And so you don't have to do a whole lot of tagging because you can just filter it by account. Just make sure the account is tagged properly. But if you want granularity, by the way, you have to use tagging, but people don't talk about that. If you want to make an instance publicly available, like an EC2 virtual machine, by the way, that's what Amazon calls instances. They call virtual machines instances. If you want to make a virtual machine instance available to and from the internet, you have to assign it a public IP address. Let me say that again because it's going to come up on the exam. If you want to make an EC2 virtual machine available to and from the internet, you have to give it a public IP address. If you don't, the internet will not see it and you will not be able to get to the internet. Well, is that true? Yeah, you can still get to the internet, but the internet won't be able to get to you. Notice that in this case, it still has a private IP address. It just also has a public IP address. I hope you noted that because I did say that earlier. I was like, hey, guess what? You're still going to have a private IP address even if you get a public IP address. So here, you've still got a 54.56.9.10 public IP address. Your private IP address is a 172.31.2.15. So you can actually get to it through both, but if you want to come from the internet, you got to hit the 54 address. Now, you can actually allow the subnet to auto-assign IP addresses. These are done through DHCP, so they are ephemeral, which means they could change. Or if you want a static IP address, you can use what's called elastic IPs. These are permanent associations of a specific IP address to a specific instance. You are only charged for elastic IPs when you have one and you don't use it. Ding. So, just to make sure we're clear, you got to use it if you ask for one from Amazon. If you don't use it, they're going to charge you like 10 cents a day or something. I don't even remember what the cost is. It's not ridiculous, but it gets ridiculous if you get 100 of them, right? You are limited by default to like 5 elastic IP addresses. So, yeah. The other way that you could get to the internet if you're on a public subnet, on a private subnet, is you could use NAT. And you might say, Michael, what is NAT? What is NAT? Network address translation. What is that? Well, just so you know, we use this in our houses all the time. We are actually on private networks inside of our houses, and usually our like little modem firewall thing NATs us out to a public IP address, which then allows us to talk to the internet. But we're running 192 addresses and 10 addresses and 172s inside of our private network. So, Comcast or Xfinity or whoever you're using, Google Fiber, they have attached a public IP address on the outside interface of your modem or whatever, fiber modem, whatever you're using, cable modem, right? And so we use this all the time. So this is no different because we would do the same thing, but at an enterprise level, where we would put a NAT gateway in a public subnet, and then we would route all of our traffic to that NAT gateway on the private subnet. Here's how this would look to give you a little visual. So we got an EC2 instance right here, right? And that instance wants to go out to the internet. It's going to go look up the route table, and the route table is going to say, go talk to this guy. And the internet gateway is going to act as a proxy on our behalf, go out to the internet, retrieve what you want, and then the traffic's going to come back and come in the same path. Well, yeah, kind of the same path, but you get the idea. But note that this route table right here for the private subnet says go to this NAT ID here if you want to go anywhere other than local traffic. And then on the public route table, it actually says, hey, NAT gateway, if it's not local traffic, I want you to go to the internet gateway over here. This is how things work across the entire internet, by the way. Usually it's dynamically done, but you just dynamically allocate how this traffic is going to flow. It's a little bit like, well, the private subnet's connected to the NAT gateway. The NAT gateway is connected to the internet gateway. That's how traffic flows. Whew, those are some messy drawings. Let's get those off of there. Questions about any of that thus far? Or you're like, I'm so excited I had that burger for lunch and now I'm half asleep and Michael's talking about routing tables and IPv4 and IPv6. Yeah, I know. Do note that the NAT gateway is going to use an elastic IP address, has its source IP for traffic if you attach one. So NAT gateways, by the way, are only for outbound traffic. It's not for inbound internet traffic. You would not use a NAT gateway if you wanted traffic to flow into an instance. NAT gateways are only for outbound traffic, okay? Cool. All right, connecting private subnets to the internet. That's where you're going to use NAT. So you're going to use these little NAT devices. Amazon has a NAT gateway service. Be careful about running it in your own account because it's going to cost you 10 cents an hour, if I remember correctly. $2.40 a day. That's going to add up to about $60 a month. Run 3 of those puppies, and the next thing you know, you're spending $200. So just be careful. If you're an enterprise, you're like, I don't care. I don't care about $60, right? But just be aware. Here, by the way, the VPC is deployed across multiple availability zones. That, by the way, you can't change that. That's the natural default behavior. And again, we're putting subnets inside these availability zones, and inside the availability zone, that's where the NAT, in the public subnet, that's where the NAT gateway is going to live. By default, we typically stick our load balancers and our NAT gateways on public subnets because here's the cool thing. Since you can't log into those devices, Amazon has to defend them, and they do a really good job, actually. So then you can take all of your resources and put them on private subnets, and guess what happens? Nobody can get to them because they have to get past Amazon's firewalls first, and they can't, like, you know what I mean? Like, that's their job to defend it. So in addition, by the way, to using NAT gateways, remember that you can actually attach network cards to these instances. So you can actually attach multiple network cards to an EC2 virtual machine. Be aware. Hold on one second. Be aware that this is not going to improve network bandwidth. These EC2 instances have anywhere from like 5 gigabits to 100 gigabits worth of backplane. Adding more network cards isn't going to make a difference, just so you know. That's just a management interface. But you can attach more, static IP addresses and other pieces to these network cards if you want to. By the way, security groups, which are the firewalls, one of the firewalls that lives inside of AWS, are wrapped around network cards. So anything that has a network card, which is always an EC2 instance, always has a firewall around it. You cannot remove the firewall. You can only ask it not to do anything. Okay. We did talk earlier about how VPCs can support IPv6. So be aware that you can actually add an egress-only internet gateway that will allow you to outbound egress IPv6. This is just like a NAT gateway. The only difference is that, this is just like a standard internet gateway. The only difference is it supports IPv6. Now, do note, you're going to have to put a route, as you can see right there, which is literally : /0, which is shorthand for any traffic that doesn't match the preceding rules or mappings. Send it to the egress internet gateway, the EIGW. Okay. No NAT instance or NAT gateway is required for IPv6 traffic because, just so we're aware, in case you missed this earlier, every IP address in IP version 6 is internet routable. There is no RFC 1918 that makes 10 addresses and 192s and whatnot private. IPv6 doesn't have that concept. Every single one of those 340 trillion addresses is internet routable. So no need for a NAT gateway for this. All you need is an egress-only gateway. This does show up on the exam. They're going to say you want to enable IPv6 traffic outbound. How do you do that? You'll use an egress-only internet gateway. Now, notice it says egress only. You cannot initiate inbound traffic to this device. This is only for outbound traffic for IPv6, okay? Just to say this, the NAT gateway and the egress-only internet gateway only allow like outbound traffic, which means they'll accept return like response connections. But if you want to run a web server, you have to use what's called an elastic load balancer, which accepts inbound traffic. The egress-only gateway and the NAT gateways only accept outbound traffic, okay? So you don't have to worry that you have somehow exposed your device to the internet. NAT gateways and egress-only internet gateways are egress only. Request response going out to the internet. So the internet cannot come into those devices, okay? Any questions about that? Okay. Let's just talk about the last thing, which is basically how do we turn on firewalls? All right, let's get our security on. Let's get it. Okay. Now, we've already talked about internet gateways and egress-only internet gateways, and we've talked about NAT gateways. So we already had this discussion. Okay, but here's an interesting thing. So notice that traffic's coming in. Where are the firewalls at? Well, first of all, the entire subnet that is around this entire like set of instances, that's a network ACL. Sometimes called a NACL, which actually is proprietary to Cisco, I think, if I remember correctly. But a network ACL is a stateless firewall. They are turned off by default. They are the only firewall, by the way, that can deny a slice of traffic. So if you're like, hey, all you guys who are trying to hack me from Austria, you're blocked. So just know a network ACL is what you use when you want to block a slice of traffic because you've let everything in and you want to block off some people that are known bad actors. That's what a network ACL is for. Security groups wrap around the instances. So in this particular case, it would wrap around this instance, and then the security group would wrap around this instance. These are stateful firewalls. One rule for request and response. NACLs require two rules for request and response, okay? So here's what you need to know is that by default, security groups allow outbound traffic, but security groups allow no inbound internet traffic to get to a box. So you are protected from the internet by default, okay? So, sans all of my messy drawings, what this means is that if we dive into this into a little bit more detail, is that network and ACLs, again, this one that goes around the entire subnet, these have rules that say I want to allow traffic or I want to deny traffic. By default, everything's allowed. Why? Because the security group denies everything by default. So in order to not complicate your life, Amazon made it so that only one firewall needed to be opened up in order for you to get traffic going to it. Okay? But these rules are read in order, by the way. So the minute the traffic matches a rule, traffic's no longer processed. We're done. If you've ever dealt with a firewall before in your entire life, you know how this works because it works the same way as the rest of the industry. So every VPC, by the way, comes with a modifiable default network ACL. By default, it allows all inbound and outbound traffic. You can create your own custom network access control list and associate it with a subnet or a VPC, right? So just so you know, if you create a custom network ACL, they deny all traffic inbound and outbound by default. This is why, by the way, most people don't use the default subnets, right? They create their own because traffic is denied by default, okay? So that's the stateless firewall. The rules, by the way, are read in order, and remember, there's an allow or deny section. So if you want to deny traffic, you can. If you want to allow it, you have to. If you do not allow traffic, custom ACLs by default are going to block traffic. If you're using the default networks, it's going to allow it. So again, try not to use the default networks for anything but just messing around, like proof of concepts and stuff. Do not put anything valuable on a default VPC with the default subnet. And you know why? Because in the console, it says default. So just don't use it. You can filter, by the way, off of source, destination, protocol, port range. You can filter off of all the standard stuff on networking. So, and then security groups are the stateful cousins of the stateless network access control list. These, by the way, can only allow traffic by IP, protocol, port, source, and destination, right? By default, they will allow all outbound traffic, block all inbound traffic. So just make sure that you use these when you usually want to just like open up web traffic or whatever, and you use NACLs when you want to deny portions of the internet. Okay. Let's see. Default security groups allow all inbound traffic by default. I'm sorry, block all inbound traffic and allow all outbound traffic. I got that wrong. New security groups, by the way, have no rules. So by default, they're going to block everything. You have to go through and like basically set it up. So by default, new security groups are going to have no inbound rules, and they're going to allow outbound traffic just like defaults. So these match. I think I just misspoke a few seconds ago. Let's restate that again. Security groups will not allow inbound traffic by default, but they'll allow outbound traffic. Okay, so just be aware of that. This can be done, by the way, by port, protocol. You can put ICMP, UDP, TCP in there. The source IP address could be something very specific. Outbound, by the way, can control destination, right? So source if it's inbound, destination if it's outbound. They're pretty straightforward and simple. They do take effect immediately. And a really cool thing is you can actually chain them together. So if you only want to allow access to members of the web security group, you can actually set your app servers to only accept that as legitimate traffic. If you want to set it so that your database group only accepts database connections from members of the application security group, you can specify a security group as your like source, which is actually pretty cool. Because then if a server is not part of those groups, then they actually can't get to you. So you don't have to restrict it by IP address. You can just do it by association. Remember, NACLs and security groups are both firewalls, right? So they will block traffic as you see fit. So this should now make a lot more sense because you get to control whether it's a public or private subnet. And even if it's a public subnet, you can control it with a perimeter firewall called a NACL. Sits around the boundary of the subnet. Inside the subnet, you can control access to specific instances using the security groups. Here's a comparison. Security groups only allow traffic in. They cannot deny traffic because they deny traffic by default. NACLs will support allow and deny, right? Stateful versus stateless. We already talked about that. All the rules in a security group are evaluated before traffic is allowed to flow. In network ACLs, it's precedence. Whatever the first match is, that's what's going to take over. Security groups require configuration by default to allow communication. Network ACLs do not. They are wide open by default unless you create a custom ACL, and that's different, right? So remember, a network ACL is a network firewall. Security groups are network NIC firewalls. They're instance firewalls. They are attached to a host. Any questions about that? Woohoo! Did we get enough information there? It was a lot, right? We just covered like networking and all kinds of stuff. All right, knowledge check. Here it comes. A single Amazon VPC can span multiple regions. Did I ever say that? Did I say that? Maybe I did. No? Wait, wait, no, it's true. It's false. VPCs live inside a single region. They cannot span regions. What action must you take to make a subnet public? What do you have to connect a subnet to in order to make it a public subnet? Good, George, that's good. Good, Kyle. See that? Route outbound traffic to the internet gateway. That's right. You have to create a modification to the route table. You got to route traffic out to that internet gateway. Good. What function does the NAT gateway serve? What's the purpose of a NAT gateway? What type of subnet is served by a NAT gateway? That's really the question. Good. So it basically allows internet traffic initiated by private subnet instances to talk to the internet. That's what it's there for. That's its purpose. Excellent. What should you use to create traffic filtering rules for a subnet, right? For a network subnet. Good. Yeah, so the network ACL is the perimeter firewall that you use to create filters around a subnet. Okay. Which ports are open by default when you create a new security group? By default, when you create a new security group, what is open? There's two answers here. So A is one of them. What's the other? That's right, A and D. Nothing is allowed inbound, but anything is allowed outbound, right? Okay. That is the end of module 3. We got about an hour and 45 minutes left together, so we're definitely going to get to the next module and we're going to get to the lab. So I'm thinking, like, let's take another 10-minute break, actually. So it's 3:44 right now. So once again, unless anybody has any questions, which we will not lose time. Just moving so that you know I haven't frozen. Just waiting. Okay, good. Let's do this. So let's come back in 11 minutes. So it's 3:44 right now. Let's just go ahead and call it. And let's make it 3:56, right? So let's give you that extra minute that I was just sitting here waiting. So 3:56. So come back. I'll put up a timer. So 3:56. Come back. Okay. See you in a bit. All right, welcome back. Okay. Questions of any type about PPCs, networking, that whole 9 yards? Any questions there? Okay. Let's get into this then. Okay. So we're going to talk about compute, and then we'll probably have actually time to take a run at the lab. Actually, let's see where we go with this. Okay. So question for you: do you all mainly use virtual machines, or do you use serverless when you do applications? What's your primary thing here? Agreed, right? I think people are still focused on virtual machines. What's interesting though is most new companies are not using virtual machines at all. So what we're finding is that people are not launching virtual machines. So, but if they're an established company and they've been using virtual machines, then that's what they stick with. So, and then what we're seeing is that serverless and containers like make up probably about 35%, 40% of kind of like digital native infrastructure, including companies that are considered kind of like legacy. But if they are like Netflix, like Fang, those guys, they are using far fewer virtual machines than ever. At least not like to host the operating system, to host the application. They're using it to host containers. So still a lot of virtual machines, but mainly for containers or serverless infrastructure. This does have a lab associated with it. I actually am going to start up the warm-up process here in about 30 minutes just because I don't want to lose the warm-up for the lab. Okay. So the idea here is that we're trying to host applications. When we want to understand the cost implications, the how to manage it, requirements, the whole 9 yards. And we want some flexibility around it. Because what we're really looking is just a host at the 3 levels, right? How do we do serverless? How do we do virtual machines? Could we do containers, which we'll actually have a whole section on that, and serverless later on. Our objective is, how do we deploy virtual machines? How do we create images so they boot really fast? How do I know which instance types are best for me to use? How can I optimize costs based on whatever my needs are? And we talk about serverless, but what is serverless? Why is serverless has been around since 2014 for AWS? Why do I care? What's the benefit of it? So here we're actually talking about Lambda, which by the way is a regional service. And we're talking about application servers hosted on EC2 virtual machines. Notice that auto scaling and load balancers are typically considered an enhancement to virtual machines, but they can be used for other things, not just virtual machines. So we got a little bit to talk about. So let's do it. First of all, you got to know there's a whole list of compute services. Most of them, by the way, are like wizards or kind of front ends for virtual machines, containerization, which sits on virtual machines, or Lambda, which sits on servers that you never see. There's also hardware that you can put inside your data center called Outpost. Everything else is either an attachment or a service for virtual machines, or something that sits on top of virtual machines, like Batch, for example, which can sit on containers or VMs, right? Lightsail is probably the one exception because Lightsail is like old school, like VPS, like virtual private servers. Lightsail is not an enterprise class offering, and most people don't use it unless they're just hobbyists, right? So Lightsail is not used in an enterprise environment typically. And VMware Cloud on AWS is exactly what it sounds like. So unless you're using VMware, right? And things like Elastic Beanstalk is a wizard for EC2. EBS is like an enhancement. That's a hard drive service for EC2. Elastic Load Balancing is the network load balancer, typically for EC2, although it can be used for others. Fargate is not even its own product, so I don't even know why they refer to it as its own product. It's actually a product that goes with EKS and ECS. So some of this is just confusing. It's just like marketing speak, right? But these are the services that we're mainly going to talk about is virtual machines, scaling virtual machines, a specific type of virtual machine, of which there's like 6, so I'm not sure why they called this one out versus the other 5. EBS, which is the hard drive service for all of the virtual machines. And then Lambda, which is not about virtual machines, is just about hosting code. So we're going to talk about all this, right? Man, these slides here. So Amazon launched 2006. First service was SQS, then S3 was a fast follower. EC2 came up a couple months after, if I remember correctly. And then, really? I don't think ECS came out in 2014, but what do I know? Maybe it was in beta. Lambda definitely came out in 2014. I thought ECS came out in 2016, and the Elastic Kubernetes service came out in 2018. I remember that one very clearly because I was open for that one. And then, serverless started showing up, and then they started creating their own processors. So, just know that they've been evolving application hosting for quite some time. But, so have the other providers, just to say this. But I will say Amazon typically leads the way in this. It depends on what product we're talking about. For the most part, they're the first to come out with serverless and all that. So just, something to be aware of. Now, the main thing when we talk about application hosting is what's going to cost us the most operational overhead versus the least, right? Lambda will cost you the least amount of operational overhead, and you will have not as much control as you would if you rolled your own virtual machine. Virtual machines give you the most control, but they're going to cost you more, both operationally and typically dollar-wise. In between that is containers, of which they have a serverless version of containers called ECS Fargate and EKS Fargate, which is serverless, and that's going to cost you less overhead. But if you decide to use the EC2 versions of those products, you might have to manage the servers. Okay? So you do less and less as you go up this layer of abstraction. So Lambda has you doing the least amount of overhead in order to support it, but there could be a hidden cost for that. All right, so that's just a big, quick settlement around which services are we going to be talking about. Let's see. Now, how do you know which virtual machines to use? Because virtual machines come in a plethora of sizes and shapes. How do you know? Because these are just sitting on top of physical hardware, right? So what do you get? Well, just to be clear, is that, hold on just 1 second. Getting notifications all popping up. Just know that there are 2 types of hypervisors available. You can use VMware if you want to. You could also use their Zen-based proprietary one, right? Virtual machines can be vertically resized. They can be horizontally scaled. There's a bunch of possibilities. All of this starts, by the way, with having a bootable operating system image. Can anyone name one of the 3 operating systems that Amazon officially supports? So Linux, Kyle, so that's good. Amazon Linux, RHEL, SUSE, whatever. What's another flavor of operating system that they'll support in Amazon? Windows. Okay, what's the third? The one that the minute you started, I think it has like a 6-hour or 24-hour charge time, like you get charged for 24 hours if you start it for a second. What's the name of that one? Yep, Mac OS. Which, by the way, I think they have M1s as well as the x86 Mac OS if you want it, right? So an AMI is simply nothing more than a bootable image. By the way, people have made Solaris images and other images. They don't work really well, so don't use them. And Amazon's not going to support you if you decide to use them. But an AMI is nothing more than a golden image. So if you've used a Cronus or Ghost or any of the standards like software imagers, then you're already familiar with golden images. The difference here is that Amazon manages all this for you. They even have an image builder. And they pre-built images. So you can actually get images from them that are sanitized and scrubbed for Linux, RHEL, Windows, Mac OS, right? You can also get them from the marketplace. Please make sure you have a relationship with the vendor before you do that. Like you can get, Cisco devices, checkpoint firewalls. You can get all kinds of stuff in the marketplace. You can also roll your own, which is actually what most enterprises do. They typically use a tool called Packer to do this, to generate images, but you can do it however you want. There's also an EC2 image builder service, which is not, I think, really awesome. It's only like a year old. It needs a little bit of work, but it's going to get there. So just know you can actually choose any pre-built image. You can roll your own. You can get some from Microsoft. You could grab some from Red Hat. You could grab them from SUSE. You could actually grab from the marketplace from an official vendor. Be careful, because if you get something from the marketplace, you might get charged for an EC2 instance, and you might get a licensing fee that's going to show up in your bill. Sometimes those license fees are by the hour, so be mindful of that. If you create custom AMIs, you have to use your software in order to boot the system, install the packages, shut the system down, and then convert it into an AMI. Those AMIs are region specific, but you can copy them to other regions using AWS's command line tools, right? So typically people do not use user data to do anything but hook the instance into an Ansible, a Chef, a Puppet, or a Salt. Those are all configuration managers that people will typically use to configure a box, even when you're just creating an image. That way you have a repeatable code-based deployment or configuration for the configuration of your operating system. You could also use Microsoft tools if you want to, right? So just a word of caution, don't do this manually unless you're just really good at PowerShell and Bash. You typically are going to use some kind of tool for that. Packer plus Ansible, Packer plus Chef, Packer plus Puppet. And so when a machine boots, by the way, you can configure it at boot time using what's called user data or instance user data. So this AMI could have all of your security and operational packages already in it. It could be patched. And if you want to make second or third generation AMIs, they could have your software, like your databases, your Tomcats, your IAS, already installed in there and configured to whatever security or operational baselines your company needs. So you might have many generations of AMIs that are based off of a first generation golden image. How do you do that? That just depends on your company's policy. General rule of thumb, you want to stick as much into the image as you possibly can, because you want that system to boot as fast as you possibly can. Virtual machines that take 10 minutes to boot do not respond to customer problems and do not respond to customer outages. 10 minutes is too long, right? Couple minutes, that's acceptable. 30 seconds, awesome. 10 minutes, you're going to be sweating while you're burning through $10,000 a minute, waiting for that machine to come up after 10 minutes, and then you find out it's still not right. Get that machine to boot as fast as you can. Stick everything inside the AMI. Now, there is a service for this. It's called EC2 Image Builder. I just gotta tell you, not my favorite. Not yet. Amazon starts by publishing services that are not super awesome, but they respond well to customer feedback. This thing is going to be gold here in about a year or two, maybe less. I know, I'm a little harsh though. It's competing against an industry standard called Packer, which is like spectacular. So even though this is integrated in with AWS, Packer, by the way, is cloud agnostic. That includes VMware, VirtualBox, etc. So hard to Hard to have this compete, right? So now one concept to know about is that almost everything you do in AWS is going to be shared tenancy, meaning your account is going to be sitting with other accounts on the same hardware, but Amazon has partitioned off and firewalled everything, so you can't even sniff the traffic. You can't see the packets on the wire. You can't see the same packets on the wire. Everything's segmented, right? So you can't see everything. But you can actually create VPCs that are dedicated VPCs, and that will actually put you on a dedicated piece of hardware or a dedicated virtual machine. Sorry, a dedicated machine that's sized just for your virtual machine. So you can actually get a host that hosts multiple of your virtual machines, or you can get a really tiny host that just fits the size of your virtual machine. That's the difference between a dedicated instance and a dedicated host. But I got to tell you something. That is the most expensive way to use AWS. The only reason you would do that is because your security compliances do not allow you to be on shared tenancy networks or shared tenancy hardware. And you had a licensing requirement that said that you can't move servers, right? In other words, you might have a software license that's subject to physical cores or sockets. Like Windows Server used to do that, SQL Server. Hell, they might still do it, actually. I have no idea. RHEL used to do that. A lot of these vendors have updated their licenses to kind of deal with virtual cloud and all that other stuff. Some of them haven't. It just depends on your license agreement with your vendor. So remember, you can have dedicated tenancy, you can have shared tenancy. The vast majority of people use shared tenancy. They do not use dedicated tenancy, by far. Now, a couple other things to be aware of. So when you go to choose the size of your virtual machine, so this is beyond the boot image, you've already chosen your operating system, that first letter that is before the number, there's only like, I don't know, 20 of those, but there's really like 7 that really matter. That first letter is the instance family type. C is short for compute, which means you have an EC2 instance that is optimized for processing. If it was an R, that's short for RAM, that's memory. If it's a G, that's a GPU system, which means it has GPUs and not just CPUs inside of it. If it's an I, it's short for I for I/O, so that's optimized for I/O for databases. D is for data warehousing. T is for testing, but also sometimes for general purpose workloads. M is for median. It's not for memory. M is for median, which means average. M is a general purpose box. How do I know all that? It looks like this. Now remember, I said there's like 20. So just know that you don't need to know all the letters. You just need to know that Amazon has general purpose boxes. It has memory optimized boxes. It has storage and compute optimized boxes, and it has accelerated compute, which means GPUs. You might be saying, Michael, why do you keep saying GPUs? Who cares about GPUs? Are they going to be running gaming on these systems? No. Remember, GPUs are really good at calculating certain hash functions. Certain kind of algorithms run really fast on GPUs. So this is for machine learning, for the most part. Batch processing, HPC, autonomous vehicles, high graphics processing, right? But not for gaming. Don't be fooled. It's not for gaming. Okay? Notice that general purpose has a 4-to-1 ratio between memory and CPU. Memory has an 8-to-1, and compute optimized has a 2-to-1. Now I gotta tell you, I don't really use this to figure out which machines I'm going to use. I'm going to show you an easier way to do this, but you do need to know this for your testing and using it, right? So for example, if someone comes to me and says, I want to run Elasticsearch, I ask them, the vendor, I got like 10,000 connections. What size server do I need? They will usually say something like, I need an 8 processor, 64 gig of RAM system. 8 processors, 64 gigs of RAM. That's an 8-to-1 ratio. Here's what I do. I'm going to share this website with you. What I do is I actually go into a website called EC2instances.info. By the way, a company recently bought this, and they've redirected the domain name somewhere else. When I press enter on this, it actually gets rewritten as instances.vantage.sh. This is an open source project that they bought the hosting rights to. And just so you know, if someone comes to me and says, I need an 8 processor 64 gig system, here's what I do. I come to this website, I hit the 8 on virtual CPUs, I hit the 64 on memory, and that instantly gives me my options. I do try to run the latest number because that means that system is going to be cheaper and faster than the previous generation. But here's the catch. All these little these letters after these numbers, they mean something. G stands for Gravitron, which means that's an ARM processor. It's not an x86 processor. If my tools are not set for ARM, that's going to be a problem. So just know that while you do need to know the family types and you need to know that they want you to use the latest generation, you're going to have to look up all those letters. So not on the exam, none of this is on the exam other than you just knowing the general classifications. But just know that in real life, you're going to have to look that up. For example, what does an R5DN actually mean? Well, here we're going to go. We're going to go to AWS EC2 instance types. And we're going to go look at the documentation. What was that exactly? That was an R5, let's say DN. So that's a memory optimized system because that's what the R's are. Let's go find out what an R5 DN is. I don't even see it listed here. Oh, Amazon. What are you doing? Let's assume then that maybe that's no longer used. So I probably wouldn't use that. Let's see what an R5, actually, you know what? Let's look at an R6 because I want to use the latest generation. Let's see what an R6 GD is, right? So there's an R6G. I don't see a GD. Oh, hold on. Oh, so it's a Gravitron processor. The D stands for disk. That means it has an NVMe RAM disk included with it. Word of caution, if the EC2 instance comes with a disk, that disk is ephemeral, meaning you can't stop that instance, and if it crashes, all your data is gone. Not your EBS data, not your EBS hard drives, this ephemeral NVM disk that comes for free with the instance. If that thing crashes, that data is gone. So try not to use the instant storage that comes with these instances unless you really know what you're doing. Bottom line is though, this is an R6 GD, which means it has an ARM processor, a Gravitron processor, and it has the extra disk on it. How do I know that, by the way? It says it right up here. Gravitron processor. With RG6 instances, it has a local SSD attached to it. But again, it says block level storage that's coupled to the lifetime of the instance. That's true, which means if that instance goes down, that storage is gone. Okay? Physically connected to the host server. So just something to keep in mind. So I don't need you to know all those numbers. I just need you to know that you want to use ec2instances.info to find the size of boxes if you're trying to look for it by size, and just follow that. Okay? By the way, I knew the R series was going to come up because of the 8-to-1 ratio. If I reduce this to 32, it was going to give me the M series or the T series, right? If I reduce this to 16, it's going to give me the C series. So notice the C's are mixed in here. As a general rule of thumb, if you have the choice between using a C6 and a C7, use the C7. If you have a choice between using an R5 and an R6, you use an R6. Try to use the latest generation if you can. Servers are considered disposable resources in cloud, so you should be stopping and restarting these things on a fairly consistent basis unless it's a data store. And then you're not going to be restarting it on a consistent basis. So just remember those general families, though. General purpose, memory, storage, and compute optimized, and then accelerated computing, okay? So if someone says, hey, I want to run a database with a high memory need, that's going to be a memory optimized instance. Someone comes to you and says, I need a database with high I/O capability, that's going to be storage optimized. Someone says, I want a GPU, accelerated. Okay, questions there? Okay. You ask me at any time. Any questions you ask at any point in time, I'll answer them. Just it's a reminder, by the way, to use the latest generation. That's what this shows. The M5X Large is cheaper and faster than the previous generation. The M6 is cheaper and faster than the M5, right? So just don't forget that. So outside of the different family types or t-shirt sizes, because also remember you can get smalls, larges, extra larges. So in addition to the family type, just remember, because I didn't emphasize this, is that there is an instance size. It usually goes small, medium, large, extra large, 2x large, 4x large. It's all multiplication. So just remember when you pick your family type, you do actually have t-shirt sizes that allow you to step up the processor memory. One thing that pops up is that people are like, what's the largest box you can get on Amazon? Well, the largest box that I've ever seen is 448 processors and 24 terabytes of memory. 448 processors, 24 terabytes of memory. That is a bare metal box. That means you have access to the hypervisor, but you can't do anything other than start virtual machines on it. So that's the largest box I've ever seen. I don't even know how much that costs because they don't tell you unless you call them or buy one. Notice that the 6 terabyte box is $54 an hour. So we can probably extrapolate that 24 terabyte box is probably about $220 an hour. Better have a good need for that. Okay. By the way, most of the boxes are like fractions of a cent. Like just to give you an example, let's say that you were running the T series, which is one of my favorite boxes for testing. Let's say we're doing the T3s. Just want to mention this. A 16 gig 4 processor box is 16 cents an hour. Man, that's pretty good. I think that probably adds up to a little like $3.50 a day. Multiply that times 30, it's going to cost you about $90 a month. Multiply that times 12, right? You can do the math from there. So, that's for an enterprise class box with a 5 gigabit backplane. Doesn't include hard drive space, but that's going to be relatively cheap. Good little boxes out there. If you're just messing around, by the way, you can use a micro or a large or a medium, right? Notice that they 4 cents an hour for a medium, right? For a micro, it's like 0.01 cents an hour with change. Rounded up, it's probably 0.02. So just know that t-shirt sizes exist for the boxes. Okay. So Ryan, I'll talk about reservations versus on-demand here in a second. It's a good question though, right? When do you use a reservation versus paying retail price? Right? Well, we'll talk about that. Okay. Do note that if you have boxes that are really not doing anything, or auto scaling groups that are not doing anything, Amazon has a compute optimizer which will tell you when you're not using your boxes optimally. You have to opt in for this, right? But all this can be exported to S3, which can show up, by the way, in Cost Explorer or Systems Manager. What this does is this allows you, by the way, to know when your systems are really underutilized. Remember, you're going to pay for a full box. If you ask for a 4 processor 16 gig system and you use 10% of it and it costs you $1 an hour, you're paying $1 an hour. So you might want to resize that box to a system that's like maybe 60 to 80% utilized instead, and you get a better ROI on it instead of using a 4 processor 16 gig box. So, just something to consider is that the compute optimizer is going to make recommendations about what's being used and how to improve your cost expenditure. Now, once you've chosen your operating system, and you've chosen your family type, well, then you're going to launch the box. You got to put it into a running state. If you are not using the EBS hard drive service, which by the way is absolutely 100% recommended, you cannot stop that box. You can restart it, but you can't stop it. Stopping, by the way, allows you to keep the reservation of the system, but you don't pay for compute capacity, which greatly lowers your costs. We do this a lot, by the way, in enterprises where we shut down systems that are not being used over the weekend and we start them up before people come in on Monday morning. You might say, well, Michael, what if we're doing the follow the sun model? Well, then just keep it up 24/7. That's not a problem, right? But note that these are the states. Pending to running. Running is either rebooting, or you're either going stopping and you're going to stopped, or you're shutting down or terminated, right? So you are billed by the second or by the hour, depending on what operating system you're running. If it's a licensed operating system, you're going to be charged by the hour. If it's not licensed, then you're going to be charged by the second. There is like at least one or two notable exceptions to that. Like I think Windows just rolled over to per second billing. Hadn't seen that before. Remember though, if you're trying to use the instance storage, which I recommended that you do not use unless you really know what you're doing, you can only terminate that box or reboot it. You can't stop it. They're going to ask you questions like this on the exam, which says, hey, what happens to your storage if you stop an instance-backed EC2 instance? Not an EBS-backed, but an instance-backed EC2 instance. And the answer is that you lose all your data, because you can't stop an instance-backed instance. You can only stop an EBS-backed instance. So if you somehow stop it, your data is gone. Now, user data is a way for you to configure a system that is at boot time. Instant storage, Calvin. So instant storage right, versus EBS storage or EBS backed. Okay. So in this particular case, if you want to change what the system installs at boot time, you can do that. You can do that. So if you want this thing to install IAS or you want it to install Apache Web Server at boot time, you could do that. This is a horrible example, by the way, because typically in most enterprises, what you do with this is you hook it into a configuration management system. You don't use the user data to do this, right? The user data is simply used to hook this system into another system that does it better, right? So most of us are not sitting here running large user data scripts in order to configure our instances, because we don't use Bash or PowerShell to configure our instances. I say that, I've met people who do, and their worlds are not as happy as they could be if they were actually using a full configuration management system. So just, something to note. User data, wasn't really designed for a large scale complex configuration. Either use CloudFormation for that, or like I said, go use a configuration management system. But you can do some minor configuration, especially if you're just messing around with user data, but mainly user data is to hook you into another system. Here, by the way, they're actually using user data with this interesting thing called instance metadata. So I want you to burn this into your brains, because this is on the exam, is that HTTP 169.254.169.254/latest/meta-data. That URL, they're going to ask you about that on the exam. They're going to say, hey, by the way, what do you use if you're inside the operating system and you want to retrieve information about the virtual machine? That's what they're doing right here, is they're retrieving the public host name and they're sticking it into a variable. So do not forget that URL. That is called instance metadata. And you can also get user data as well. So you can actually see what someone told. When someone does this, you can actually retrieve it using that same URL. just change meta-data to user-data. And you can retrieve the boot information that was given to this box when it was first booted. It can only be referenced from inside of an EC2 virtual machine. So this is mainly for scripting purposes or for troubleshooting. Okay? So user data is used to change a box at boot time. Metadata is used to get meta information, metadata about a box. This includes, by the way, everything that Amazon knows about the system. Attached volumes, operating system, AMI ID, public DNS name, private DNS name, all of it can be retrieved from inside the operating system. You can't configure it, but you can see it. Questions of any type? Okay. Oh, by the way, I was supposed to turn something on. Hold on. Nope, not that. I'm supposed to turn you on. Okay, good. All right. So remember that even past the AMI, you can use user data to change something when it boots up. Okay. And then metadata is just information about the system. So user data is to change information about how an operating system boots, what it's going to install. Metadata just gives you information about the system. So Kyle, I don't think you probably can, I don't think you can disable metadata actually. If you're running on Amazon's infrastructure, I think you can block it by putting in like an IP table or something so people can't loop back against it. But I don't think you can disable the service. They might have added something for that, but I don't remember that off the top of my head. But metadata is always enabled by default. Okay. If you want to log in to an EC2 virtual machine, guess what? You're not going to use IAM. You're like, huh? No, you're not going to use IAM. So just so you're aware, if you want to log into an EC2 virtual machine, you have to use what's called key pairs. Most of us are familiar with this because username and passwords have been falling out of favor for like 7 years or 8 years now. So most people are not using username and passwords to log in anymore. They're using key pairs unless they've got some kind of authentication subsystem like a Kerberos or a linkage into Active Directory as an example. But most of the time, people are using public keys, at least to initially get access to a system. They might switch over to a more single sign-on option after that, right? So public keys are basically where you have a private key, consider that to be the actual key, and your public key is actually stuck on all the systems that you want to log into. Consider that a lock. So you got the key, you're the only one who has the key, everybody else has a lock. Now that's not cryptographically accurate, but it's a good way to think about it. You're the only one who should have your private key. Your public key should be disseminated out to everybody you want to log into. Keys are part of EC2. They are not part of IAM. So when you want to log into a system, you have to use a key to make that happen. Key pairs, which are like the two halves, are generated at the time that you create a virtual machine, or you can create them ahead of time and just refer to them. Typically, people will start out with a certain like key pair, and they'll just use that key pair at initial boot, and then change the key pair after the system is boot and like hook them into a single sign-on system or whatnot. But key pairs are usually used as the first thing you're going to boot into, right? So private keys on your box, you refer to it via SSH, or you use it to decrypt an RDP connection. So whether it's a Windows box or a Linux box or a Mac OS box, you're going to use a key to get access to your box. So the other thing is, other than logging in, is that you have to tag resources typically. It's a good practice because you can actually control access to resources based on their tags. So you can tag an instance as production, you can tag an instance as non-production, you can tag it as highly sensitive, non-highly sensitive. Tagging is an essential part of your AWS strategy. So typically if you tag, you get better reporting and better control. This has a deep meta to it. I'm just letting you know that you should tag, not that like what the tagging strategy actually is. Now, in addition, just so you know, they do have launch configurations and launch templates that you can use inside of Amazon to predefine the creation of your EC2 instances. This is required, by the way, if you decide to use autoscaling. But just know that there's launch configurations and launch templates. Please use launch templates. Don't use launch configurations. Templates are more up to date and more in line with how AWS likes to use their stuff. Okay, so you're going to get more modern features if you use launch templates versus launch configuration. Sorry, versus launch configurations. Okay. This, by the way, a template usually defines everything from what you're going to boot, the instance type, any attached disks, the network interfaces, any tagging, how you're going to configure it, any mappings along those lines. All right. Okay. I'm going to talk about this last piece. We're actually going to stop in the middle of our EC2 presentation. We're going to do a lab, and then I'm going to finish the rest of this in the morning because I really wanted to get you to a second lab by the end of the day instead of you just hearing me talk all day long, right? So let's talk about it. We'll talk about instance storage and Lambda and all that tomorrow, but our lab is actually going to be, oddly enough, about building kind of our VPC infrastructure. So it's a perfect time to do a lab. Okay. We're just going to happen to use EC2 instances. Okay. Get ready for this one because this is going to be all over the exam and it's all about costs. That's all it is. It's about costing. It's different ways to pay for and use Amazon EC2 instances. It's got very specific characteristics. So we're going to talk about reservations, savings plans, which are really just like reservations, spot instances, and on-demand instances. Before we do this, I want you to really note these qualifications. You will use reservations, which is going to give you like a 72% discount on AWS if you go all in with them, for a 1 to 3 year workload, meaning a workload that you're going to run 24/7 for 1 to 3 years. And this is if you know exactly what your CPU utilization is going to look like over that time period. Like in general, you can burst above it and all that stuff, but like it's a steady state growth. You have an idea of how it's going to grow. A savings plan is also a 1 or 3 year commitment, but this has more flexibility to it. You don't get as deep of a discount, but this is when you know you're going to run it, but you have no idea what the compute looks like, and you still want discounts. Spot instances are different because reserved instances of saving plans are for 24/7 workloads. Spot instances are for workloads that can withstand interruption. Reporting, batch processing, genomic data, geographic, oil and gas. Spot instances, what you're doing is you're bidding on Amazon's unused capacity. They're going to give it to you for a period of time until someone needs it. You're going to get a 2-minute warning and they're going to shut your instance down. You may say, Michael, why would you do that? What if you want to report, it costs you $10,000, but instead of costing you $10,000 because you've got 30 days to run it, it costs you $2,000 because you use spot instances. And when you run that report every 2 minutes, it just writes its data out to an external database or data store or S3. And you just save the company 80% of the cost to run a massive report because you use spot instances instead, because you're not under a time crunch. You just need to get it done within 30 days, right? That's what spot instances are for. By the way, spot instances can be mixed with on-demand instances and with reserve instances to run your web servers. If the spot instances go away, the on-demand instances just take over, right? That's called a fleet, by the way. So Amazon has made this really easy to do. And then on-demand instances are the second most expensive out of that dedicated thing that we were talking about before. This is full retail price. For example, on-demand instances are going to cost you $1 an hour, just as an example. Spot instances could cost you 10 or 20 cents an hour, and savings plans and reserved instances could cost you 30 or 40 cents an hour. So these are significant savings if you commit upfront to giving Amazon money. If you're not interested in giving Amazon money, well, guess what? Then you're not going to give you a big discount, right? So let's talk about reservations first. This is the one that has the 1 to 3 year commitment, but they come in flavors. So reservations come in flavors, right? Hold on just one second. So what you got to know is that you can get standard reservations, you can get convertible reservations. Sorry, my phone just went crazy there for a second, right? Is that you can get standard reservations, you can get convertible reservations. What's happening here is that with standard, you are committing to running a virtual machine at a specific data center for a specific amount of time. With convertible reservations, what you're doing is you're saying, well, I want to be flexible with the t-shirt sizes. And so let's make that very flexible. And so instead of maybe you give me less of a discount, and in exchange, I'll get more flexibility. With standard reservations, you're not going to get as much flexibility, but you get a deeper discount. So what this means is that with a convertible reservation, you can say, look, I want to buy 5 M5 X larges in Virginia, and I want to do it in data center 1. With a standard reservation, they'll give you a pretty deep discount. With a convertible reservation, they're not going to give you a deep discount, has much of a deep discount, but what will happen is that if you want to take those 5 M5X larges and split them up into larges, you can do that. If you want to combine 2 of the extra larges to 2XLs and run a larger instance, they'll let you kind of t-shirt size combine the instances if you want to, right? So they kind of allow you to manipulate things as you need to. So convertible instances have more flexibility associated with them. By the way, I'm going to go over this again tomorrow morning. I just want to forewarn you. I'm going to cover this again because it's such a complex topic. So if you're not getting it, don't worry about it. We're going to cover it again tomorrow. We're going to repeat this. So reservations are that 1 to 3 year commitment. Savings plans are where you give Amazon $10,000 as an example, and they'll give you $14,000 or $15,000 worth of compute. This is a bucket of money that you can spend across any size, OS, or tenancy of compute that you want. And you can also buy this for machine learning plans as well. So there's lots of options about how you license, but this is not where you reserve instance sizes. This is where you reserve money, okay? Now here's a little comparison. You do not have to memorize this, but compute savings plans and instance savings plans are buckets of money where they give you a discount if you spend it against compute. RIs are where you reserve instance sizes. I want to reserve an M5X large. I want to reserve a T3 micro. I want to reserve an R6GD extra large, right? So these are a little distinctive. So remember, both the savings plan and the reservations are for 1 to 3 year workloads. If you're not going to run it for 1 to 3 years, these don't make sense. Don't do this. Okay? Otherwise, just use on demand. Run it for 4 months and then give it back. Don't use savings plans or reserved instances in that case. And they're going to test you on that, by the way. I got a steady state workload that's going to run for 4 months. What do I use? On demand. You're not going to use one of these. Okay? All right. That's the last bit that I'm actually going to cover. And I know I still have to talk about spot instances. I know I still have to talk a little bit about on demand, but we're going to pause there because I just want to let this sink in, and then I'm going to go back over it again tomorrow, and then I'm going to cover spot instances, and then I'm going to cover on demand, just because this is probably one of the hardest topics inside of like this one. The rest of it's all just services, so it's easy to pick up. Questions of any type? Okay, well, let's get hands on then. So let's do this. All right, we were on slide 37. Okay, just making a quick note. All right, so let's get into this thing. Okay, so I want you to go in and open up Lab 2 in your webage.quicklabs.com. This is what we're going to do, by the way, until 5:30. So you've got about 45 minutes, a little less, to do this. What you're going to do is you're going to open up Lab 2, and you're going to start the lab, and you're going to create a VPC, create some subnets, create an internet gateway, and then you're going to route internet traffic in the public subnet to the internet gateway, which is going to be fun. Then you're going to touch the firewall, and then you're going to launch an EC2 instance into the public subnet. Then you're going to connect to the web server. I just want to mention, by the way, the most common thing that causes people to fail here is they copy this wrong. So please make sure that on step 50, you are making sure that this user data is copied into the system and that there are no errors in this as you copied it. Use this copy button right here, okay? And then you're going to connect to that web server, then connect to the EC2 instance in a public subnet. You're going to use Session Manager for that again, okay? So for those of you who got hung up on that last time. You're going to create a NAT gateway, but be aware, well, that actually doesn't matter. You're going to connect a NAT gateway, and then create a security group for those private resources. Then you're going to launch an Amazon EC2 instance, and then you're going to connect to the EC2 instance on a private subnet, so a private subnet, not a public subnet. And then you have an optional task, and there's actually two if I remember correctly. You're going to test connectivity from the private instance to the public instance, and there's a second one where you're going to retrieve the instance metadata. That's what we're doing for the next 41 minutes. So go ahead and hit the Start Lab button and get cracking. Remember, you want to get detail-oriented on this, right? And if you have any problems about navigating where you're at or whatever, please let me know, okay? The minute you're done, you can go take a break. Just know at 5:30, we're going to cover a few exam pieces, and then we're going to stop at 6, okay? Any questions anybody has for me? Let me know now. Otherwise, let's get cracking. something to kind of be mindful of is that this is the whole AWS certification landscape. Notice it starts with cloud practitioner at the bottom, then goes to the blue hexagons, which is the associates level, and then we've got the professional level at that point in time. So notice then that we've got the purple specialty exams over on the right-hand side. So you're taking the class that is associated with Solutions Architect Associates, but I just want to say this, and Amazon doesn't say this enough, this class will not allow you to pass the exam. It is not the class to actually get you ready for that exam. There's actually an exam readiness version of this class that's a day longer that includes a whole lot more study material, and even that class will only get you about 80% there. And so just know that you have to like study above and beyond this class. What's presented in this class is only going to be about 60 to 80% of the material. It's going to be honestly more like 60. So Amazon didn't say that enough. No, they have no classes that get you 100% across the finish line to get ready for these. Okay. So, you know, the exam preps that we're talking about are mainly like to get you like beyond there, right? So what happens is that as part of taking this course, like, and let me be clear, this course is more than just advanced architect, like, and more than the architecting on AWS. The one that you signed up with WebAge is an enhanced course that is over and above the official AWS offering. AWS offers no exam guidance when you normally take the course, but as part of taking it with WebAge, we're going to help you figure out how to pass the exam. So by taking this particular course with WebAge, we are going to help you figure out how to get ready for the exam, because normally AWS, the official class, doesn't do that, right? So this whole conversation we're having right now, this is not part of the normal AWS curriculum. Normally there is no discussion about how to pass the exam. But since you're here and you're with me, and that's all I do is help people. Well, I do more than that because I'm also a consultant. But mainly when I'm doing training, I help people like take these courses and get ready for the exam. So you're in the good hands as far as like if you want to take the exam. Now, if you look in the materials section of the GoToMeeting, you're going to see a bunch of resources there, 4 files in particular, including a general ramp-up guide, which is going to be super heavy, a specific certification study guide that we have written for you so you can pass the exam. And by the way, we have used this guide a lot, meaning this is a battle-tested method for passing the exam. We do this all the time. We have passed thousands of students this way. And I say that because we're also interested in you having the skills. In addition, there's some supplemental labs, which we're not going to talk about till tomorrow. And you all are going to get free practice exams as part of taking this course and registering it for it with WebAge Solutions. In conjunction with you taking this course, doing a little bit of extra study and the practice exams, you are going to be prepared to take this exam and pass it. But do not let me trivialize this. It is 40 hours of study to get ready over and above you taking this class. Okay? So this class has all the extra stuff you need to get across the finish line, but you are going to have to put in some work outside of this class to get it. There's no boot camp that I know of in the world that can actually like double sync you and get you ready to go. Okay? We get you 80, 90% there. The rest is you doing practice exams, and we're going to talk about what that looks like. And you might say, well, Michael, hold on. Are these test dumps? No, they're not. They're officially approved AWS practice exams from a partner of ours called Tutorials Dojo, and they will help you get ready for retrieving the material, passing the exam, answering questions about all the services, and understanding the scenario-based questions that Amazon's going to ask you and the things they're looking for. So, just so you know, if I gave you I think some of you kind of panicked for a moment. You were like, wait, why did we take this course if we're not going to get ready for the exam? You are going to get ready for the exam. What I'm saying is the AWS official curriculum does not get you ready for the exam. This course is going to set you up for success. Okay. So does anyone have any questions about that? Because I feel like I see we need to talk, and what do you suggest pass the exam? Hopefully I already answered those questions or concerns, but I'm all ears if someone has another ask.
You mentioned there's a few files somewhere at GoToMeeting invite. Is that what you said?
Yeah, so if you go in the interface and go to materials inside the GoToMeeting interface, you know, where you like share and stuff like that, there should be a material section. Does anybody else see that?
I'm using the web version and I'm not seeing it.
Okay. Well, don't worry because we're going to email you the materials, right, for you to take a look at tomorrow. So, but if you're using the web version, I don't know where that's at, right? If you're using the GoToMeeting application, there's a materials section that will allow you to see it. So,
great. Thank you, sir.
yeah. So don't worry. You're going to have it. There's no way you're not going to get it. Matter of fact, there's actually going to be a second zip file that has even more stuff in it. We're just trying to get all our T's crossed and I's dotted, right? So the point to all that is that we're going to give you everything you need to pass the Solutions Architect Associates. And that's what we're going to be spending 30 minutes a day on at the very least to make sure that you're prepped for that. And if we end early on Wednesday, just know that we're going to spend some extra time going through practice exams as well, just to make sure that you get exposure to how to use these things. So I know that we only have a few minutes left and we have to stop at 6 o'clock for a variety of reasons. But I just wanted to share that with you, is that you're going to get a study guide. You've got the official AWS ramp-up guide. You're going to get access to some quick labs, which is going to allow you to get more hands-on experience, even over and above what's in the class. And then we're going to get you access to the practice exams, which, you know, just to say this is that ideally, if you haven't done this already, if you use the same email that you used to register for this class and you go to portal.tutorialdojos.com, you can do that now if you want, or you can wait till the last day. That's up to you. But if you go to portal.tutorialsdojo.com and you actually sign up for an account, within 24 hours, you should get an email that says you are now registered for the Solutions Architect Associates practice exams, because we've already pre-greased your email address with Tutorials Dojo. So just by signing up the class, we've already like set you up. We haven't registered you because we can't do that. But if you sign up with your email address, you're automatically on an allow list that's going to grant you the Solutions Architect Associates practice exams. But you can do that on the third day, or you can do it now. Either way, just know you're going to have to wait 24 hours because they're in the Philippines and it takes them about 12 to 24 hours to process requests, okay? Taking these exams, by the way, is going to be one of the keys. In addition to reading some white papers, just to be upfront about it, you're going to have to read a few white papers and maybe look at some digital training. The supplement certification guide that we're going to use, which I'm actually going to pull up so you can see it, is going to be supplemental from you actually using these practice exams. Now, obviously, I have a whole bunch of stuff here, but let's go take a look at the associate exams. These associate exams that you get access to, the main focus section you're going to focus on is called the review mode exams. And as you do a set of these, what's going to happen is that John Bonso, who works with AWS to make sure that these are all legal and above board, he has a photographic or an didactic memory, slightly different. And so what happens is that when you get hooked in with his practice exams, he gives you the wrong answer, the right answer, why they're wrong, why they're right, and he gives you the source AWS documentation to understand exactly why, if you need to dive into that. Oh, I did click on this. I wonder why it's not loading. So we're going to take some time in the morning to cover this before I even get back into EC2 to make sure that you have some exposure to this. But this is where you're going to resume and understand the material at a slightly deeper level, because this is where you get to practice answering these questions, right? Questions like, hey, we're going to scale a bunch of instances. It's going to have a high throughput workload performing small random IO operations. Which of these is it going to be? Well, the minute I saw that, I pretty much knew the answer, because it's going to be high throughput, small performing random IO. That's going to be provisioned IOPS. I'm going to teach you how to attack these questions and understand which keywords are going to give you which service and which subservice you need to use. So that's what we're going to be doing for at least an hour over the next 2 days, is we're going to cover those kind of like strategies for how you attack this. The only other thing I want to show you, because I know we're kind of like at time, is that there is the certification guide that you were looking at before. So this certification guide basically includes the white papers and the labs that you need to kind of get ready. Now the labs are a little bit of overkill, so you don't necessarily need the labs per se, but you are going to need to skim your eyeballs across those white papers and do the practice exams to really pass the exam. Notice that, this typically represents about 40 hours of training. You can go faster if you want to, just by studying a little bit more, and not everybody needs to do 40. Some of you are going to need to do about 10 or 20. Others of you might need to do a little bit more than 40. I will tell you, though, that even in the worst case scenario, most people end up doing 40, or if they've got some experience with AWS, they end up doing 10 or 20 hours worth of study. So that's like 2 weeks, 4 weeks if you're doing 5 hours a week, okay? So just want you to be prepared for that. We are going to talk more about it tomorrow, but we are going to set you up so you can pass the exams, and we're going to show you exactly how you're going to know when you're ready to take the exam. Like specifically, you're going to have a very clear metric that if you're above this metric, then you're ready to go take the exam. And thus far, everyone who's followed this program to date has passed the exam on first try. Now, that's not a guarantee, so I want to be very clear about that. But everybody who's done it thus far, this is battle tested. They passed the exam on the first try, and they've actually had the skills to execute from a design perspective as well. Okay? Questions of any type? Mark, you asked me about Skill Builder. That's a supplementary training. That's an adjunct to this. So that's something you can go back through again once you're done with the class. So that just, like, if you have a hole around networking, you can go back in and look at networking again, right? That's all that is it's a supplement to this course. Sorry, Mark, you're asking for the URL for what? Oh, it's in your student guide, actually. Hold on one second. Let's see. Oh, you know what? I probably just need to go into Skill Builder because I remember it always gets a little finicky because the site's not fully up yet. Let's just go back in. Let's see. Architect on AWS online course supplement. There it is. There you go. There it is. Okay. All right. Unfortunately, I have to run off and teach another class, which I'm actually late for, right? So we're going to review these pieces in the morning. So we're going to talk more about the exam certification pieces, and then we're going to talk about EC2. For those of you who weren't able to complete the lab, just know that you can run it again. So feel free to do so. Most of the time, it's either a permissions problem, which is very rare, or it's a step that was missed. So, just to say this is that we can do a little bit of deeper dive the next time I see y'all, okay? So I'm going to run off to my next class, unfortunately. But for those of you who got hung, we'll talk about it more tomorrow, and then we'll review the exam pieces, the exam prep tomorrow as well, okay? Thanks for hanging out with me today and being interactive. We'll see you tomorrow.